You can feel it.
Yeah, have you ever like the moving walkways at an airport or like a mall or something like that? Everyone in here has probably been on those. I mean, maybe in
Yeah.
different countries they don't have them, but where you're walking normally on the ground and then you get on that thing and if you just keep walking like a good brisk walk, the minute you get on it, whoa, you kind of like pick up speed and you're like, you can feel the airflow against your face, obviously, and then you can obviously notice, and you're a little tipsy too sometimes right when you get on it because it's a change of speed and all that. But then once you're on it, if you walk with it versus against it, now I know there's the differences of the airflow, so to like test it further, you'd almost have to build some kind of shield around you or something, but there is a noticeable different physics. Like when you're walking with it, you're being propelled through the medium, let's just say, air, whatever you think the medium of the just that we live in, like meaning not the ground, not the celestials, but everything in between the ground and celestials, whatever we call that, the air, the medium, whatever, space, etc. You're either propagating faster through it when you walk with it, or you're walking against it. And even though your relative speed based on the walkway is the same of your steps, there is a difference in the physics of whether you're propelling forward or through the medium faster or slower by going against it.
I suggest that if you actually shut your eyes in that scenario, and be careful, so if you got on the walk, so when you step on the walkway, you get accelerated, right? So straight away there's that. But once you're on the walkway and up to speed, if you shut your eyes and walked, you would have no perception of your motion.
Dazza and I are going to be at the hospital. We're going to be at the airport with blindfolds on. People are going to be like, "What are you doing?" Be like, "Oh, we're just testing some stationary Earth theories."
Well, either get arrested or end up in the hospital, right?
Yeah. But dude, so the wind flow you obviously would feel. So I think most people, like even if you did this test, I think most would be able to because of the flow of the wind against your face. So that alone, but you'd have to somehow control for that. But you're saying that, okay, if you blindfolded me and we actually did this, or if you did it, are you claiming that you would not be able to decipher the difference? Walking with a moving walkway or against it?
Yeah, because it's like the same as deal when you're in an aircraft, right? You can walk up and down the aircraft that's doing 900 miles an hour, and it doesn't feel any different than when you're on the taxiway.
No, I'm suggesting that there is a difference, though. Because like if you're going 900 on that airplane, when you start going walking with it, going from the back to the front, you're actually picking up. You're going a faster rate through the medium. Now, granted, if you have all the wind blocked, you're not going to have the wind flow against you, but you're still going to have just like the viscosity of space, essentially.
So, would you think the faster that it goes, the more of that force would be present?
Well, it would be like a proportion. You're saying if you're going 500, then you take a step and you're going 500 point something miles an hour versus if you're going 2,000 miles an hour and then you move a little faster?
Yeah.
So the state of affairs here is that no instrument known to mankind is able to detect what we're claiming that humans here can detect, and no humans have been reported to have detected it in a double-blind test. So there we go.
Who's tested that? Who's even tried? Are you just saying,
saying
no one's tried it?
I'm just saying there to date there are no double-blind tests that have been reported where a human was able to detect what you're claiming could be detected by a human.
But has anyone even tried to test that?
People have been trying to make instruments that'll measure it for years. I don't know if anyone's done any double-blind studies, but...
Yeah, I'm just saying, who's done a double-blind with people with blindfolds on, putting them on walkways or airplanes? So to say it doesn't exist is not really... It doesn't matter if no one's ever even tried it. If no one's tried it, then... if you're talking about the humans picking it up, like human perception of walking, like if you did it in a bus, even like 80 miles an hour, and you have even if the floor is not level, you could make a level floor. Like you could do some construction a little bit inside the bus and make sure you have a perfectly level floor. Then you'd have to make sure you're driving on level ground too. But I mean, that would be a project. You're claiming that you can't tell the difference? You don't think you'd be able to tell whether you're walking with one of those walkways or against it?
Okay,
It's
so
extremely easy to tell that every time you're walking with it, every step is a little bit more challenging because you're picking up more and more speed as you're walking upon something that already has the velocity to it. And when you walk against it, it's like even you can do this with like a treadmill.
no,
Tell the
that's what I'm
difference.
saying is in a double-blind study, if you were shielded from outside influences like holding onto the or non-moving rail or shielded from the wind, the sounds, if you were deprived of all the other senses that you could use to determine which way you were going on that moving rail, and it was or that moving belt, and it was level, and you were blindfolded and earmuffed and shielded from the difference in wind, that's what I'm saying is you could not tell which way you were walking on it.
I think a high percentage of people would be able to. I think there'd be some that are just very like aloof people that might not notice because they're just so aloof. But your brain has to actually calculate for that horizontal vector as you're walking. It has to actually calculate for it. And you can directly feel it. I'm 100% sure with a blindfold I could be able to, and I think many, many, many others would be able to as well. It's very easy to tell. It's like walking on a treadmill when it's moving under you is not the same as walking on the ground either. Like you can't tell the difference between that, like walking on a treadmill at the same speed or walking on the ground. It's totally different. On the ground, you have to propel yourself forward. On the treadmill, you're more like compensating for the thing moving with your feet. It's totally different. Completely different physics.
Well, I guess what we need is some flat earthers who are up for going on a train ride, because it could be done on a moving train too. You would need, I guess you'd have two people both blindfolded, but one of them would be filming the other with a camera, but they couldn't see what they were filming, so neither one would know which way the train was really going. They would be blindfolded, and they would walk forward and back and forward and back in the train, spin around a few times, forward and back and forward and back in the moving train, and then the subject, which was blindfolded, would tell the person doing the study, which was also blindfolded, each time after spinning around and walking forward and back in the train, they would announce which direction they believed they were going with or against the travel of the train. And the camera, of course, would be recording, and it would know what the truth was, and then we could find out if the individual was actually able to statistically reliably determine that. And it would be a double-blind study. So that would be very, very interesting.
Yeah, some of these ones we're talking about are slightly different scenarios. Like being on a moving airplane or train or bus is one type of scenario where you've already been brought up to speed, so you're going 60 miles an hour or even 500 in an airplane, whatever it may be. You've already been picked up to that speed, and if there's a consistency of speed as well, so it's not moving, and you have all of the fuselage or the you know basically able to break all the wind and in terms of all the wind friction. So that's one type of scenario. The moving walkway one is a little bit different because you're kind of exposed to the air, and then you're also like propelling yourself faster or slower along the ground.
Well, that would be true for the
They're kind
train.
of similar though.
Yeah, the train is good because it could be leveled. Airplanes fly at an upward pitch of a couple degrees. So that's going to be hard to eliminate practically from the test. But a train could be going on level ground, and it doesn't have an upward angle of attack. So the train car floor is going to be basically level, and it'll be going nice and fast. And I think it's a perfect place to test the theory.
Yeah, but whether humans can pick it up is only one factor.
Well, so far there's no known instruments that can, and people have tried. people have definitely tried to make the absolute speedometer, they call it. So if humans can detect it, humans would be doing something that no known instrument or device has been shown to do.
I just don't think maybe enough effort has been put into it, perhaps. So wait, what do we need? What if we add cameras to this, and it is tracking the movement as it progresses one way or another? Then that would indicate movement. No.
I guess one person could actually do a double-blind study by himself by just putting the GoPro on a head mount but being blindfolded, and walk forward and back a couple times, spin around a bunch of times, so to reorient him or disorient himself, and then walk forward and back a couple times. Yeah, one person could do a double-blind study because the camera would be the unbiased participant in the study.
Yeah. Now, what other sensitive sensors maybe could be utilized to maybe detect? Maybe to confirm or to maybe continue to push the understanding of science.
Well, the patient or the subject of the test would be wearing a GoPro, and it would be filming out the windows of the train as he walked up and down in the train. So the GoPro would record which way he really was walking, with or against the train's direction. And then he would be saying, okay, I'm walking with the train, I believe I'm walking against the train's direction, and that way the GoPro would record both the subject's belief of what he was doing and the reality of what he was doing.
Yeah, and then maybe measure see if there's any symmetry or symmetry breaker with the observations.
Hard. You'd have to almost blindfold them before they even get on the train or the airplane, because if they're already on, if they're just taken up there, a lot of people have a very refined sense of direction, like north, south, east, west, and which way they were turned around. Because if you were just on an airplane and then they put blindfolds on you, you would just know. You'd already know like quite a bit about your position and whether which way the front of the airplane is versus the back, unless they like spun you around or did some kind of a.
Right. I mentioned spinning him around. He would have to spin around, and he would have to do the test multiple times, spinning around between each of them, because if he just does one test, he's got a 50-50 chance of being right. And then we would never.
But even spinning around could be kind of now you're going to disorient them. They're going to get dizzy. Plus, they might still be able to pick up even from being spun around which direction they are. Like that's another test you could do: is spin people around and be like, okay, are you facing west, east, north, and see. Some people would be able to. Some people are very sensitive to like how they're moving. Whether they're in an elevator or not, or like some people are very sensitive to motion, which is a whole argument that the Earth is part of that. The Earth is not in motion. Is that there's a significant difference between being at rest or being in motion. With all the physics, with your like vestibular system and your body and everything.
That would be another great double-blind test. Which someone could also do by themselves, blindfolded with a GoPro mounted on them. Although they'd have to go to where there wasn't sounds that told them which way they were facing, because just about anywhere you go, there's subtle sounds, coming off the breeze in the trees or the birds or the road or something, and it tells you which way you're pointing.
Yeah, do you know what's interesting? I think there's an owl where the ears are not essentially symmetrical. One is slightly at a different area on the head. That way, it can, as it's traveling, it can echolocate with more precision, perhaps. Interesting concept.
been a bit in and out tonight. While these examples are already interesting of how to test it, what I found kind of fascinating about my understanding of what Alan was saying in his talk is he didn't seem to be making the claim that a blindfolded person on the constant moving train could tell that they were in motion. He seemed to be making the claim that because they can't tell, they're wrong. That if we already say that we know the train's in motion, the fact that someone on the train doesn't feel it proves that there's something wrong with that frame of reference, because it contradicts what he's saying we already know to be true from what he called the lab frame. So it seemed like a very interesting inversion of like what the argument normally is here. I don't know.
Well, wait, could you say that again? I mean, I follow what you were saying, but could you maybe lay out what you meant again? By the way, Alan, yeah, he was not talking about blindfolding people or whether they could tell whether they're on a moving train. No, I'm not. We were talking about sort of something different, although it's related, just in
No, it
terms
is
of.
related. No, but that's the thing, is that like very often the debate is there a way that someone like blindfolded, no external sensory input, the blinds are closed, they can't see the ground rushing by outside of them, could they tell from within the train that it's moving? So like that's often what gets debated. But then in Alan's presentation, that didn't seem to be the structure of what he was saying at all. What he seemed to be saying was that he agreed, yeah, you couldn't tell that you were moving on the train, and that's a problem because we do know that the train is moving. Which I don't know. It was a unique take on the whole topic, is as much as I could say about it.
Yeah, you mean couldn't tell that you're in anything different than the lab frame?
Yeah. Or really what he seemed to be saying was that his belief was that mainstream physics claims that all frames of reference should agree on how much energy something has. So because the person on the train can't feel the train's motion, that means they don't know that the train has all this horizontal energy as it moves horizontally, and that's the problem he had.
Yeah, but he was also referring to the difference in the physics of having that horizontal movement. Like whether a person could feel it or not is kind of like a subjective feeling thing, like of a human being. So like even if we just remove that and just talk about the physics, was he not talking about the horizontal vector that would have to be accounted for so that they would be different? And then the one that gives the predictions that are accurate to the physics is the lab frame, the stationary one, whereas all these other frames that claim the motion would have to factor in that motion with the physics that are going on in that system. And the fact that they don't means it's just conceptual. Now, that's some of my wording, but it's just a conceptual overlap without the actual physics all being. And that's what I was asking before. Like if you had one of those little, like a little laboratory pod or whatever, and you put it like inside of a train versus on the ground, you're doing experiments. That was my question for Wesley. Like, wouldn't you have to factor in, if you were going to be the guy that was evaluating all the physics, if that thing was just sitting on the ground, you might have a little bit of airflow just from the wind, and you'd factor that in. But if it was on a train, you would have to factor in the motion of the train.
No, not for anything. Like the example he was giving was someone who tosses a ball up and then like catches it. And if you did that on a stationary train or you did it on the moving train, like he's correct that the difference between those scenarios is the horizontal motion of the train. But the horizontal motion doesn't change how long it takes for the ball to go up and come back down. So whether the ball has a lot of horizontal motion and you throw it up and it comes back down and still has all that horizontal motion, it takes a certain amount of time, and it takes the same amount of time to go up and down if the train was stationary too. So the mainstream claim is that the horizontal motion of the train doesn't affect anything that you could time or measure inside the train. So I kept asking, like, okay, so what is the disagreement between these two perspectives? And the only thing we kept coming back to was the motion of the train itself. And like, yeah, definitely, that is the disagreement between the perspectives. If you're on the train and can't feel anything inside the train that tells you it's moving, you would say that it's not moving, and someone outside it would see that the train is moving. So that's one thing that we can say is different between these two frames, the motion of the train itself. But that's fine. Like, the mainstream perspective doesn't have any issue with the motion of the train being different between different perspectives. The interesting question is whether or not the motion of the train affects things inside the interior of the train. So I thought that maybe he was building towards something like that, but then he seemed to just say, no, it's like it's just the point about the motion of the train itself that he's talking about. That someone outside the train sees it moving, someone inside the train does not see it moving. That's a difference. Okay.
What was the essence of his logical argument? Was it that if Earth was moving, XYZ would happen or be observed, and XYZ is not observed, therefore Earth cannot be moving? Or what was
No,
the
he was
basic...
he was just saying that from the lab perspective, on the ground on the Earth, the train has some velocity, so it has some kinetic energy. But from the perspective of someone on the train doesn't feel like it's moving, so the person on the train doesn't perceive the train to have that horizontal energy. So the person on the train says the train doesn't have this horizontal energy, kinetic energy, and the lab frame says the train does have this horizontal kinetic energy, and that was his problem. Like, that was the problem he had, was he was bothered by the fact that the total kinetic energy of the train would come out to be different depending on how the train was viewed.
How would an observer on the train measure that?
The horizontal motion.
Or the energy, or whatever. Yeah, how... does he think it's possible for the observer confined strictly to the train to know the train's velocity?
That's what I was trying to sort of figure out with him, and it seemed like he was saying no, that the person strictly confined to the train, he agreed wouldn't have a way of knowing it was moving, and to him that was the point, that was the problem, because he was saying we do objectively know that the train is moving from the Earth perspective, so the fact that the person on board the train doesn't realize that it has all this horizontal forward motion and the kinetic energy associated with that means that their physics is wrong. He was just sort of asserting this new principle that I've never heard anyone else assert before, which is that the motional kinetic energy of an object needs to be the same to all observers. And then pointing out, because it's not, that means there must be something wrong with physics, I guess.
Well, that's why I brought up the Oberth effect with him, which he hadn't even heard of.
What's that effect again? I'm not sure I know the name.
The Oberth effect.
Oberth?
Yes.
I'll get up.
That's the fact that when a rocket's reaction mass is taken to a higher velocity relative to some other object, right? Like a rocket leaving the Earth or a rocket leaving the sun, the total energy of the system, like the most efficient way to consume that reaction mass is to consume it at the time when the vehicle is at its highest speed, which would be at perigee. If we're talking, in relation to the Earth, or periapsis, in relation to the sun, right? So
I know you're gonna bring this back to how it's related, right? You're gonna land. This is gonna be a home run once you land this. How is this related?
No, it's just, well, he's talking about, his problem is the total. He's trying to say that, like, somehow physics doesn't take into account that that one system, one system relative to another isn't taking into account the total energy of the system. So, like, in the example of the rocket, right? if you completely ignore its relative motion to another object, when you expend your reaction mass, you still have the delta V is no different. Like the amount that you will be able to accelerate the vehicle has not changed in either situation. But the total energy of the system, in regards to what he would call the lab, from the perspective of the lab, right? Um, the lab frame that he was calling it is drastically different, right? That's why he was bringing up the train, right? The example of the train, the perspective of the energy of the train from within the train versus the perspective of the train from
Yeah, from
observer
the
that's
ground.
not on the train.
Yeah, but isn't that also in the definitions of the words? Like the lab frame, like we know what a laboratory is. Like if you've been in a laboratory, you're in a lab, they're on the ground, they're on Earth somewhere. Usually there's not laboratories out on the ocean, although I did ask him what he thought about, like, if you're on the ocean, where's the lab frame? But a lab is on the Earth, and then a train is something that is moving, propelling itself on the Earth, which is essentially the lab frame. So the whole, like, you shouldn't even say put it on a train unless you mean a train, which is something that's in motion in relation to the Earth. That's what a train is. Like it's going 60 miles an hour or whatever it is, down the tracks in relation to the laboratory, which is sitting next to the tracks on the ground, not moving. So, I mean, is that not the definitions of even using a train in the first place? Like by definition, that's what it is. A lab frame and then a lab frame plus a train motion.
I mean,
Labs
it's
can
just. Go ahead.
labs are anywhere that you're doing a study. If the observers are on a train, then the lab frame is the train. And in fact, the Eötvös effect was discovered from a lab on a moving ship.
Well, you could have a lab on a train, but
Yeah, a lot of people are asking for that.
I mean, but being at rest on the Earth is like the default for for like a foundational frame.
From what I got from his whole presentation is that he thinks for some reason that science doesn't account for the fact that the energy of the system is different from the perspective of someone that's not on the train versus someone that's on the train, right? Because he was using throwing the ball on the train as the example, and the total energy of the ball for someone that's like in the train throwing the ball versus someone that's observing the ball from the outside. He thought that pointed at some kind of a physics conundrum or something. To me, it wasn't really clear what was he really with this whole presentation, and then all the different examples that were variations of the same thing. Like, what was his whole goal of that?
What was the conundrum?
Well, the null hypothesis was Earth is stationary. That was the title of it. So.
And the only problem with that, which is I think kind of what Dazzle was trying to go with, what if this was on Mars? But you could have just said, well, what if on the train you had another like miniature person on a train that was in that train, and you were looking at it from the perspective of the person on, in that train, then they could just use it and say, well, then that means the train is not moving, even though the results would be identical for if you had like a train on the train, so to speak, right? And then you have an observer that's comparing those perspectives, right? For every layer of it, that's why it doesn't make any sense to use that as a null hypothesis that the Earth isn't moving, because that would also be true for if there's a train on the train itself, like a little miniature train on the train, and there's a ball being tossed up on the little miniature train, and you're looking at it from the perspective of the miniature train versus, from the frame of reference of the little miniature train versus the frame of reference inside the train, right? And then yet another observer on the outside that could then look at all three of those, right? Like,
Yeah. I like the train on the train.
Yeah, from the little train, the big train's not moving.
Um,
Well, hopefully we can get into some other questions about space and falling in space, because I'd love to ask maybe some of the physics people here eventually. And maybe I'll just put the question out there, and we don't have to go to it now. But in your opinion, do you think with the sun falling through space, is it over time continuing to accelerate as it falls through space? And that would include the Earth as well. What do you guys think? Has it stabilized? Is it within like a range and it'll always be within that range? Or do you think it's continuing to gain momentum as it falls? Thank you.
Well, the mainstream model is that the sun is orbiting the center of the galaxy at about a constant velocity. So maintaining about the same velocity as it goes around approximately a big circular orbit around the center of the galaxy, as kind of the planets do in turn around the sun.
Yeah, thank you. Do you think that the center of this, maybe our universe, do you think it's stationary? Or is that also because it's also dense? It's also falling in space, right? It has nothing to support it. So because there's nothing to actually support it, and it's heavier than all the other dense objects in space, it would also be falling in space and accelerating. And
Well, I don't think there's I don't think there is a center to the universe.
Yeah, there is no center to the universe, and so if you wanted to take it all the way, right, the sun is following a fairly circular orbit around the center of the galaxy, but the galaxy itself is also rotating around the group of local galaxies, their center of mass, right? They're orbiting around each other, and then that group is orbiting relative to some other masses that are in the universe.
yeah, the ultimate
So
mass. Is there one ultimate
there is
mass?
there is no ultimate
Nah,
mass because
not that I know of.
This is a theory, right? Because we
as
can't
far
tell.
as that we can as far as that we can tell, the universe is it's it's distributed pretty evenly.
Okay, any other thoughts? Would there be one ultimate mass, or would there be two equally ultimate mass, or three equally ultimate mass? Or there has got to be, what is the probability of two equally, like down to the decimal place, equally massed objects and dense objects in space? Or would there be over the time, because of a collection of mass attracting mass, essentially it would be growing, and it would be ultimately one most dense area within the galaxy or universe?
Well,
And
there are high density areas that are growing as a dense cluster of galaxies pulls in other galaxies, but there is a limit. There's a limit of stuff that is within the gravitational reach of a particular dense cluster, and eventually it runs out of nearby material to pull in, and then that's it as far as we know. So a cluster can grow to a point until it's depleted all the available material that was in reach around it. But as far as would the entire universe collect into one giant ball, the answer would seemingly be no, since there's already so many clusters that have finished growing and are spatially far away from each other enough that they're not going to pull each other in to each
Also,
other. They're not.
dark energy
Yeah.
is also actively pushing apart the more distant galaxies, and so at a certain point, the dark energy is pushing them away faster than the gravity is pulling them together, and so those galaxies are going to get further and further apart. So theoretically, assuming, and that's where all the assumptions goes, right? Because nobody knows what's fueling that dark energy. Is that going to start slowing down at some point? Is it going to reverse at some point? That's where the big crunch idea comes in, where eventually the expansion will stop and then turn around and then collapse in on itself. That's like the limits of our knowledge of the physics of the universe, and nobody knows which way it is. But theoretically, if that pressure from the dark energy that's pushing everything further apart kept going, then at one point we wouldn't be able to see we would only see the galaxies within our local group, and we would no longer be like the horizon. Our horizon of all the other galaxies would no longer be visible. And then, so if our knowledge from this civilization disappeared, then theoretically, like future civilizations would look out and be like, oh, there's only like 4 galaxies in the entire universe because all the other galaxies are now beyond their horizons.
Okay. Thank you, Jake. So, what about the Great Attractor? In your opinion, you guys, do you think it's an area of dense material? And what, if so, what's making it dense?
It probably is an area of dense material, and the fact that a collection of material that dense could form in a way that was unpredicted, I mean, to me, points to the limits of our knowledge at the present moment. I mean, I do think that a lot of the fine details of these theories about cosmology and gravity are suspect and are placeholders and are, attempts to make models on limited information, and then we see things that are anomalous to those models, and it's like, well, okay, so maybe gravity is like stronger possibly than we thought it was, or there's other types of material we don't know about. I mean, those are all the different competing hypotheses. And I will say, like, I think that the physics media vastly overstates the confidence, and that we are much more groping in the dark than the type of presentations you'll see in the media would like to say.
Oh, for sure, for sure. I mean, okay, imagine in theory there is. Oh, Gio, did you want to jump in?
I did, but it was on the last topic, so go ahead.
Oh, okay, thank you. I was just gonna say really quickly then that yeah, in theory, if there is a black hole, even on the flat Earth in this like space area
Yeah.
or on the globe model, yeah, it would be interesting because even sending a probe potentially would be lost. That probe would be lost to the dense object, right? If it was just pulled to it because of the vacuum or the attraction there. But yeah, thank you, and I appreciate you guys.
Well, no, I mean, if you guys want to shift the topic to some of the outer space stuff, I mean, that's all good. I just but I was reading a comment just from the conversation before. Left Lane, are you still there? Because I want to ask you. Okay, so Right the Hand, he typed, can a moving train ever be not moving because of someone else's perspective? And what happens if that train hits someone? So what about that point? So if you're on a train, you're going like 60 miles an hour, and then you have a little train in there, and that little train is going a little, just going slow. So Left Lane, like you were saying, like, well, to that little train, the big train's not in motion, right? Didn't you say that?
Yeah, from the perspective of the little train inside the big train's not moving.
Okay, but if the big train then hits something, and everything, and the little train and everything has all this crazy momentum, and it smashes, comes up to the front, and everything explodes, the big train was moving the whole time, right? So what actually was happening is like the big train was actually moving. Just because you can kind of perspectively, that's why that comment, that's what he's saying. Like, can a moving train ever really be said to be not moving just because of someone else's perspective, like the little guy's perspective? But once that big train hits something, the whole thing is exploding. So obviously it was in motion. The little guy, even if the little guy, you want to like selectively be like, well, he can't tell it's moving or something, but it is still moving.
But the little train on the inside, even if the big train wasn't moving, actually was not moving, it doesn't look any different to the little train.
Well, whether it looks different to the little guy or not, like I hear you, like whether it looks different to him or not, but he's still in motion. Like if you had a little ant on a train, the ant's walking around. Yeah, I hear you. The ant might be like, well, doesn't think it's in motion or something. But once the train hits something, that's just what he said in this comment. Once it hits something, you surely would know that you were in motion. Therefore, how can you ever really say from the little guy it's not moving when it actually is moving? Like we can't lie to ourselves and pretend it's not moving.
Well, the little train doesn't know.
Yeah,
but he does know when it hits something. He does know.
No, what if something hits the train? You don't know if it's the train hitting something or something hitting the train.
No, because when the train, let's say the train ran into a wall, the whole train would like, you've seen those like slow motion of things.
Yeah, but how do you know the wall didn't hit the train?
Because you lunged forward when it hit?
Yeah, and if something hit you head on, you would also lunge forward. So you don't know
No,
if the train.
you would probably launch back. If I'm trying to think,
No.
if you're just in a train and something smashed you, you would go back. You wouldn't go
Nope.
forward.
No, you would go forward.
Compared to the train you were in.
Yeah. Because if something hits the front of the train and lurches the entire train backwards, and you're not strapped into your seat, and you stayed in your same position in space as the train lurched backwards, then from a camera filming inside the train, it would look like you had been flung forwards.
Yep. It's the same if you're not looking outside of it. You hitting something or something hitting you would look the same.
It'd be kinematically the same.
Yep.
That's
Just
just
like
not
if somebody,
true, though. Like
no,
Jeremy's
if
saying
you
with
were
the
like-
car hitting the tree or the tree hitting the car, there's definitely.
Well,
But
different
I mean,
physics.
no, Gio, it would be like if your car was on the middle of the freeway, you were stopped, and somebody was going in reverse at 60 miles an hour, and they hit you. It would be the same as that car being still and you hitting it at 60 miles an hour.
I don't agree. I think there would be differences.
that's the thing we could test that
The one
of,
that's in motion. The one that's in motion.
of the two things collide with each other. Doesn't matter which one did we say was moving, or does the only thing that matters was the relative motion, the difference in motion between the two of them?
Yeah,
Like,
it's the difference of motion.
Blue car, red car come straight at each other on the highway. Doesn't matter if the blue car is going at 40 miles per hour and the red car is at 0, or vice versa, or they're both doing 20 at each other. The mainstream physics view is that the only thing that matters is the relative difference in motion between them.
And that's
sort of what
That's
Sorry,
also
go
why
It's experimentally verified on top of that.
Yeah, that's why in airplanes, when you're flying at each other in airplanes, you cannot tell who's going faster because you're up in the air, and so you don't know which person is going which speed. You just know that the speeds together. That's the only thing that you can
Yeah,
determine.
your closing velocity is all that you'd be
Yep.
able to determine.
Yep.
Well, that's not true because you're moving at a different rate through the air and over the ground.
Well,
Well, if you were
that's
referencing that, we're talking about if you're not referencing some external thing.
Yeah.
Pump out the air.
This only works if you have windows, right? Like if we're assuming we have windows when a car is hitting something or something is hitting a car, but if you close it in, you wouldn't be able to tell the difference.
That was what I was trying to get into with Alan, is he kept referring to a constant velocity as being part of the dynamics. And I was saying, like, no. Dynamics is when action happens. Like, dynamics is when you hit something. Dynamics is when there's change. If you're just cruising at a steady, constant velocity forever, there's no changes occurring. So I don't understand what he meant by dynamics in that particular case here.
Well, I have a question though regarding constant velocity, because in theory, right, constant is only maybe like us when we round up a number, like for pi 3.14, when in reality it's far more technical than that. So as Earth is supposedly traversing around its orbit, it's continually accelerating both forward and backward, right? Acceleration, because it's gonna, as it's if I'm not mistaken, right? Because it's closer to the sun in some times of the year, and there's just not a constant speed. But you guys can correct me if I'm mistaken.
Yeah, I mean, if we want to take into it, like when we talk about like the ground and the train in relative motion, we are neglecting out orbital dynamics like that. I mean, you are right that the pure version of this type of test of relative motion, if we want to be really, really, really precise, could not be two cars smashing into each other on the Earth because of all of this. We'd really be talking about like two rocks in the middle of empty space with nothing else around them, like a truly isolated system.
No, but can I just say a quick interjection? There would be a difference, though, in the physics of one thing hitting another. Like if a tree ran into a car or a car ran into a tree, because one of them actually has like the momentum behind it. And so when the physics, like when that collision happens, the thing with the momentum I understand some factors would be similar in terms of them though, like whether one's hitting the other, etc. Like if somebody punches you in the face versus your face runs into their hand, or runs into their fist. But there is a difference of the one that was in motion that's hitting the thing that wasn't in motion in terms of like how like the parts of the car would go flying. Or in that case, like if you're talking about some kind of asteroids out in space or whatever, I don't know, out in space. I mean, a lot of this like hinges upon the whole outer space idea, and and these, these types of claims.
We could approximate it with a clean room with okay, the perfect laboratory is a sealed-in box floating on a tank of liquid mercury, with like many layers of platforms with shock absorbers and gyroscopes and stuff to try to like zero out any influence from the outside world. So I could also say that if we don't want to go out to space.
One way to look at the tree scenario, Geo, is so forget about it being connected to the earth temporarily, and imagine a big tree swinging on a rope into your stationary car. If you were just sitting in that car, you would see the same thing, right? You'd see this tree looming up at great speed towards you. Then all of a sudden you would be, the front of your car would cave in. You would be smashed against the dashboard. Everything in the car would start to fly forward because the tree's momentum relative to the earth would have pushed the car backwards, right? You'd see the car moving backwards if you were standing on the earth and watching it fold out. But from within the car, you wouldn't know the difference in the scenario as to whether or not you were in motion or the tree was.
I completely and 100% disagree. And I think we could actually prove it with a slow motion camera setup. If you had like a car and then you have like you get like a tree, I guess, and you speed it up to 50 miles an hour. Because, dude, in the car, like if the car's the thing going 50 miles an hour, there's a bunch of different physics involved. I understand there would be some overlap. I'm not denying that there would be some overlap. But there's definitely a difference. Like in the car, when you're going 50 miles an hour and you hit something like a tree, everything in the car is already going 50, so it's lurching forward. The physics of the explosion of the parts that hit, like usually the thing that's moving gets damaged more, is often the case. Like that's what happens in car accidents. Generally, the one that was in the motion generally has more of an impact or more damage. That's another factor, but there definitely is going to be a difference of the whole impact of that whole car moving 50 and then hitting a tree versus the tree just hitting the front of the car. It's definitely going to be different. Like all the stuff in the car, like if the tree just hits the front, most of the stuff in the car would stay fairly still. Yeah, you could lurch forward a little bit if it smashes into you. Whereas if you're going 50 miles an hour, if you had like stuff on the back seat, that stuff's all going to fly towards the front.
That's not Geo, but that's not that. Maybe what your intuition tells you, but we know experimentally, kinematically, and even in the software that modern cars now, they're all designed and the crash tested on software. And that software will show you that the distribution of the deformation and the damage and everything would be 100% identical, whether the tree was stationary and the car hit it at 60 miles an hour, or if the tree hit the car at 60 miles an hour. It would be kinematically the same.
Yeah, I think a good example that you might be able to look up is so when they do side impact testing, pole testing of cars, I think more often than not they will run the pole into the vehicle rather than the vehicle into the pole, and the footage inside will show you that what happens inside the car is the same.
Now, I do need to caveat that a little bit. Because and the example, the tree is not a great example of it because the tree is rooted into the ground as opposed to like a tree So what we're talking about is like if a tree was free floating in space, the mass of a tree, and the car hit the tree or the tree hit the car. Now, obviously in real life, a tree is rooted into the ground. So it's actually much more like the ground, or the tree with the ground below it rooted into the ground, and the mass that includes that hitting the car, right? Because that's going to be different, right? Because obviously a tree is a very I think a better example would be like a metal, like a steel pole, which only weighs maybe 50 or 100 pounds, right? Like a steel pole that's floating in space, and then a car hits it at 60 miles an hour is obviously very different than a steel pole that's like embedded in concrete and hitting it, because it's the pole plus all the mass of the ground and stuff that's hitting it, right? So you kind of, I think maybe that's what's throwing you off. So in our examples, it's assuming that the two are free floating in space. The better example is two cars hitting each other at relative speed, because the friction between the wheels at different speeds is pretty negligible. So that's a lot more like free floating in space than like something that's actually rooted into the ground. And maybe that's where the confusion is going into it.
Not at all, but you're just trying to like disparagingly ad hom to try to pretend like I'm confused about something just because you might disagree or have some different viewpoint. But no, I don't have any confusion based around any of that, nor did I think that was a factor in what we were talking about. Obviously, if you're going to have a car run into a tree, you couldn't just take a log of wood. You'd have to have it attached to something that would like relate to the ground if you're going to try to make it exactly the same. So no, I wasn't thinking that would have been the difference. I mean, if you're going to replicate it, you'd have to have basically a tree that's attached to something like that's almost like the Earth. I don't even know how you would do that, but I guess you could try to attach a tree to like some bed of a truck or something that's like, but then you'd have to replicate the roots and stuff. You might not want to do a tree because of all that, but maybe like a pole or something. Like if you had a pole that was cemented like 2 feet into the ground, and then that was the thing you were going to change, and you'd have to have like some kind of a 2-foot thing of cement that was like as stable as the ground would be roughly, and then run that.
It would be even more than that, Gio. Like, I mean, theoretically, to be 100% accurate, you would basically need the Earth with the tree sticking out of it, slamming into the car at 60 miles an hour, versus the cart slamming into it at 60 miles per hour. Then that would be completely kinematically the same, right?
Yeah, but we
Obviously,
can't. We can do one and we can't do the other. We can't throw the Earth at 60 miles an hour because the Earth is stationary. But you can throw a 60-mile car into a tree. That's kind of the crux of the whole thing. One of them you can do, one of them you can't.
Right. But we can do it. We can do it at different. That's obviously an extreme scale there, right? And obviously, we wouldn't actually need the whole Earth. We could just probably, once you include like a few hundred cubic feet of ground that the tree is in, the result would actually be pretty much exactly identical at that point. The rest of the mass doesn't really matter. The whole idea is that the tree is pretty immobile, especially if you're not able to break the tree. The tree is basically immobile in reference to the car. So once you build up enough mass, it's going to be pretty much immobile relative to the car. But the whole point of this though, Gio, is that at smaller scales you can do actual tests, and this has been done, countlessly, and we know that the actual result is precisely the same, right? And if you model it in software, and modern software used for car crashes, for testing the new car designs for car crashes, we know that kinematically they're exactly identical.
You do like an air hockey table, and just like record the sound of a collision, like the decibel level, depending on how fast the pucks were moving, and like compare for their speeds versus their comparative relative speed to each other, what variable actually determines how loud of a bang is made when they come in into contact with each other.
Yeah. Anything else, Gio, on that topic, or anyone else? Because yeah, hopefully we could get back to maybe dark holes or black holes one day, or the
Black
dense
hole.
areas of yeah. Because I wonder, and thank you for taking my question earlier. Because yeah, I wonder, like even these dense areas. To me, logically, it would make sense that it would also be falling in space, maybe even faster than the less. Well, actually, maybe not, because in space, I think.
Everything is falling around something else in space. Everything is in motion. There's nothing that's stationary in space as far as we can tell. Everything is in motion around something else, and everything is falling or falling into something else, or attracted into something else, falling into each other.
Yeah, so in theory, right, as these dense objects are continuing to fall without friction, wouldn't it seem to accelerate in any sense?
Well, from a Newtonian perspective, they would be like Earth's orbit around the sun. Like you said, it's accelerating and decelerating as they go in perigee, or it would be apoapsis, periapsis, right? They would seem to be accelerating and decelerating. But from the Einstein, but there's actually, if you had an accelerometer, you wouldn't be able to detect it because from Einstein's perspective, you're just following a straight line through a geodesic in curving space, right? And that explains why you cannot detect it accelerationally. You cannot detect the change. You cannot detect that as an acceleration as Earth changes speed around the sun. For the same reason that if you if you turn on the accelerometer on your phone and you toss it into the air, the accelerometer will instantly go to zero. The moment that the phone leaves your hand, like if you have it logging the acceleration, the accelerometer on your phone will instantly go to zero when it leaves your hand. And even though it's now decelerating as it's traveling up, and it'll come to a complete stop at some point, right, where it reaches its maximum height, and then it'll start falling and accelerating again. That whole time, the accelerometer on the phone is reading zero.
Okay,
Even though obviously from a Newtonian perspective, it's changing velocity, so it's accelerating from a Newtonian perspective.
thank you, Jake. So, do you know when we have objects actually hit something like the ground and it stops falling in space? There's nothing to stop it falling, right? In your opinion?
I mean, if two things collide.
Well, yeah, if they hit each other, it would be kind of like something stopping it from falling, and whichever one has the bigger mass is going to be moved less than the one that has the smaller mass, right? Or
Okay,
if there's
let's
a
say there
massive
is.
disparity in mass, yeah.
Sorry, I didn't mean to interrupt. Let's
No,
say
no,
there's
go
no
ahead.
collision. Let's say the trajectory is clear, the path is clear. I don't know if that's even possible. Maybe in reality it's not possible. So this could be just a waste of time. But in theory, I guess if it was just no obstacle in the near future or far future, in theory, would it continue to accelerate as it falls in space? Or do you think it's because
Yes, it would continue to.
Sorry, go ahead.
Well, that's the whole thing. Is like if we imagine.
You got to bring in terminal space velocity.
No, I mean there is no terminal space velocity. It's going to. I mean the two things will continue to accelerate until like that's what an orbit is, right? It's continuing to fall into something, and then until it and then moves far enough away, then it turns back around, right? That's why the objects like in the local cluster, the galaxies in the local cluster, they're all orbiting one another.
It appears that way. Or it
Yeah,
can.
it's great
Like you
that you
said,
believe that, Jake.
they're also orbiting the great attractor. They also orbiting the great attractor, which we don't really know what that is.
At least being pulled towards it. I mean,
But you believe it anyways. That's okay.
And there's nothing to believe or not to believe. It can be measured that
Yeah,
we are
you're
being
just
pulled around
interpreting.
it.
Yeah, you're just interpreting what you see in the sky.
well,
You ain't been there, so you don't know. Good job, though, Jake. You can keep believing it.
It's
Where's
not a
the
matter of
sample?
belief; it's just where the evidence.
and I think
It's only where
everyone's
the evidence takes you.
their senses.
Yeah, one sense, the eyes, your sight.
Yeah.
The sense of sight is the only sense you get to use when looking at the lights in the sky. Good job.
Essentially, we are. Yeah, essentially, we
Well, I
are
can't
limited to our.
smell them or taste them.
Well,
Although is
that's
anyone
not
we're limited
exactly
to our
accurate, right? Because
imagination.
we can also look at these objects in the infrared.
No.
We can look at them. We can look at them within the radio
Yeah.
spectrum and see
And
radio
good.
emissions coming off of them.
Yeah,
And then
you're just seeing. Yeah, you're just seeing.
cosmic events can not only be cosmic events can not only be seen in the electromagnetic spectrum, but they can be seen gravitationally through LIGO as well.
But just seen, right? One sense.
Yeah, of course, centrifugal force. We can confirm that, but you have to, in order to experience that, you have to have like something tethered. Like if you're going to take like a ball and you like wrap a string to it or something, like yeah, you can do that. Like put a ball on the end of a string and spin it around and have that. But that's something that's attached, to something physical. If you have the other type of centrifugal force, or like you're in a car and somebody turns really hard to the left, and then your body slams into the thing on the door on the right. But that has to do with like moving objects on Earth, and then one of them is being propelled outwards and it's running into something. So one of them is running into the wall, the other one is attached to a string in terms of centrifugal force that we can replicate. But we can't replicate this like free falling orbiting effect, And then I think extrapolating something like Cavendish has a whole bunch of problematic factors in there. So I'd like that. To me, that's not confirmed in any way either, and involves a whole bunch of assumptions. But I mean, what I like, with all due respect, like that response you gave, I would say is like kind of an ad hoc, piecemealed way of thinking about certain things that we can see on Earth, like centrifugal force or the little Cavendish wiggling, and then make these larger extrapolations that balls would then orbit around balls. I think is a leap without like all the steps of like variables and logic that would be needed to actually confirm that those physics actually come together to create this kind of free fall around a sphere effect.
So there's something called a gravity well funnel, which is just a big funnel with the correct curvature on it, so that as something is rolling around, it's like a penny wishing well, but the curve is such that as the object gets closer to the center, its weight causes a greater force towards the center, and if the curve is the correct to match the claimed relationship between masses attracting masses and distances, in other words, just reducing with the square of the distance, then actually orbit can be illustrated or visualized, demonstrated physically that way, using the funnel to create that square attraction relationship. I'll drop a link.
I want to add one as well that it gets us away from gravity. It's a demo I was doing with my students this semester. It involves an electron beam and a glass tube, and I think the glass tube is filled with argon. And when you fire the electron beam through the tube, it glows green. It's very cool to see. And you just fire this beam through the tube, and you just get this solid green beam going through the tube. Okay, now you bring a magnet towards it, and you can start to make the beam bend in all these different ways. You're not touching the beam; the beam is inside this glass tube. But you can make it bend by moving the magnet around it, and if you align things properly, you can get it to form into a near perfect circle. So it is, I think, in a loose sense, you could call that an orbit. It is making a circular motion around another object, in this case, another magnet that is bending its motion around itself, and you can form it into a circle, and you can use compass needles to check which direction the magnetic field, the magnetic force would be pointing at each point in space to see if a force, that is strictly speaking just attractive or repulsive, can lead to circular motion under the right circumstance of the right initial velocity, shot towards the thing that it's then attracted to.
All right. Do you have any like video or anything to see that in action? Because I mean, really, like the thing that's in contention in a way, like if you shoot a bullet, because I'd have to see what kind of circular motion you're referring to. And with magnetism, you can definitely get all kinds of things. Like you can even get like ferrofluid. Like people always talk about like water doesn't stick to balls and water doesn't curve around balls. People say that, but if you actually take like ferrofluid, you can actually get like the ferrofluid liquid to attract to a ball, like a magnetic sphere, like a piece of metal, like a magnetic spherical little metal thing, and you can get the ferrofluid to attract to it. So I mean, yeah, with magnetism, you can definitely get a whole bunch of different effects, also even with sound waves. But I guess like with the orbiting thing is, if you had like you throw a ball or something and the arc of that ball, we all would agree that thing, it arcs, and then you have like your slope and the ground, which actually like in school they actually treat they essentially teach like a flat Earth physics in terms of throwing a ball or shooting a bullet,
Mhm.
meaning that they don't incorporate the curve of the Earth. Which, yeah, I realize at 8 inches per mile squared, it would be negligible within a small range. Therefore, if you're only throwing a ball 100 feet or whatever, it's that's why they don't necessarily incorporate. But they don't in the physics of it. But the difference would be if you threw a ball and it's arcing, and let's just say you threw it like over a cliff or something, and it could just keep arcing. It would keep arcing. What I would say is that it would arc and arc and arc, and then eventually, if you had like a deep enough, like the Grand Canyon or something, that it would just keep going. That ball would end up just going down. It would never arc and then start looping around back on itself. That's the physics that's claimed with the orbital and with the globe thing, is that at some point, the claim is 17,000 miles an hour, ISS, all these claims, that there is that physics where something is shooting like an arc over the ground, but instead of just arcing and then just going down, 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 because if down is just down, like the vector of down is universal, down is down, up is up, then yeah, you can throw something that's arcing, but eventually it's just going to end up going down, and it's not going to loop down around and start clinging to the to the
Only
underside.
because of aerodynamic drag, though, Gio. That's the only reason why the ball loses all its sideways momentum, is because the aerodynamic drag of the atmosphere is what takes away all its forward motion, and it just starts falling down.
Yeah, but even if you had a Grand Canyon or some kind of huge, like you're really high, and then you fire a rocket, and even if that rocket is propelled and it was arcing, like throwing a baseball, but instead it's a rocket and it's arcing, I'm just saying, like, it would keep arcing, and if there's no ground to hit, it would keep going until, yeah, if it ran out of fuel, it goes straight down. Or even if you kept it fueled, you're right, you could maintain an arc of some extent, but still, the claim is at some point that thing is going to, that propelled rocket is going to actually, loop back around on itself and do the orbital effect, which is what's claimed. And I realize with magnetics, we could get in, because like you mentioned magnetics, and that does bring in other forces involved. But I'm just saying, like, that physical concept, even though some of you folks may believe it because of ISS or because of these things, but can you really say to yourself that you've confirmed that actually does occur in the physical world, that things will loop back around on itself that way when they're in free fall, rather than just falling, as we know the physics, down to the ground?
Let's just sort of bringing up the magnetic example, because I was trying to understand if the thing you have contention with is the idea that a force can result in an orbital circular motion where things never finally crash into each other; they just go around each other forever. Or if your contention is with gravity specifically, causing that. Because then I would just say that what I see with the electron beam example is exactly a demonstration of a force creating a circular arcing motion that never crashes, that the things exerting force on each other never actually crash into each other. They could just go around each other forever under the right balance of force. Now, it's not gravity, so maybe the real contention is about gravity specifically, but the electron beam shows to me an example of a force producing, the phenomenon of things cycling around each other without ever directly hitting.
Well, I mean, if you have different physics involved, you can definitely get various things going on. Like I mentioned, the ferrofluid, like on a spherical magnet, you can get the ferrofluid to stick to it. But that's involving, I mean, the oceans are not necessarily ferrofluid in that relationship, So just because you can replicate some things doesn't necessarily mean that. I mean, like, for example, you can, like, that quantum locking, you can see that quantum locking where things are like orbiting a hovering. But I mean, if someone were to say, well, hey, that means the moon is a quantumly locked thing. I mean, yeah, there's quantum locking on the ground. It's possible the moon could be that, but just because you can replicate something on the ground doesn't necessarily mean that the moon is hovering up there like a quantum locked thing. I mean, that's the theory or an idea. So, I mean, I hear you with magnetics, and I'm looking at this video here, trying to see with the looping part. I see the light kind of loops up around this thing. Because I mean, what the thing that's being claimed is that an object in free fall will loop around a sphere. I mean, that's really like a physical object. will do that. You know, the way they claim like satellites, and I mean, if we're talking about orbit and all of that, so it's it's not really claimed to be like an electromagnetic type of
No, it's not claimed to be
force.
that. I was just looking for the thing that's difficult to test about gravity is that gravity is a tremendously weak force that we have to go out to these scales of planets and moons and stars and stuff, and then that's in contention because these are scales so much outside the scale that an individual human can directly interact with. So then you get into the institutional question of our reliance on institutional information about space. So that's why I was going for something that's much, much more testable, and is maybe not a perfect analogy, but I thought was a decent analogy for looking at, can a contactless force, a force acting between objects at a distance, result in circular motion that does not cause the objects to eventually collide with each other, but instead just keep looping indefinitely.
Yeah, it turns out that it's possible, Geo, that if you imagine the Earth was a point mass and you were just standing on a magic shell at radius r, you could actually throw something into orbit with your hand, or even just drop something and it would orbit the point mass in an elliptical orbit. So the physics of suborbital projectiles is the same as an orbital projectile. Just the Earth gets in the way in the case of the suborbital scenario.
Wait, how can you get an orbital effect from a small scale? I mean, we know the arc of things are being thrown or being propelled, but they come down. There's the downward vector to Earth. Go ahead.
Yeah, so the downward vector is towards the center of mass of Earth. So if you throw something and you get what over a short distance looks like a parabola, is actually the top end of an ellipse. And if the Earth didn't get in the way and that ellipse could continue back around the point mass of the Earth, you would actually get an elliptical orbit. And so that, throwing something on the ground, the physics is the same as trying to put something into orbit, but you just need more speed to get a bigger radius to put something in orbit, that's all. So you can sort of show empirically by experiment on Earth the mechanics of moving from a short range projectile to an orbital projectile without having to change your physics at all.
Yeah, but just taking a part of like the arc of like if you throw a ball or something, like taking that arc and then extrapolating that arc is like part of something that would be endlessly looping around a sphere is still a leap in terms of physics, like making that leap.
It's not a leap in physics, it's a leap in your ability to trust that the physics extends. So the physics of an elliptical orbit around the Earth is the same as the physics of a projectile motion on Earth. It's the same thing, just one is faster and bigger than the other. So the simplification you do in high school and in general actually is to assume that gravity is parallel and you get a parabolic path. But if you want to deal with a projectile that goes a bit further, you need to deal with the fact that gravity is radial, and you will get an elliptical path. So, a parabola and an ellipse look quite similar at apogee there. But if you go far enough and long enough, you have to actually abandon the parabolic path and do a proper elliptical path to work out where your suborbital flight will intersect the Earth. Not to mention the fact that the Earth is rotating while it's happening and it's curved, but all three of those things have to be included to work out where an ICBM will land, for example.
And you've confirmed the physics of orbits. Because I could just as likely say you're doing an extrapolation fallacy. You're, throwing a baseball or shooting a bullet and seeing how that projects over a planar surface ground, and then you're just doing an extrapolation fallacy, saying, well, if the Earth was a sphere, and if the gravitational vector all went to the center of the sphere, and if that thing could go at 17,000 miles an hour at a very high altitude, et cetera, it would actually loop around this sphere. And the only place you can show that is essentially, claimed organizations that you can't confirm those physics ultimately, like you're going off of government agencies that claim to launch things to space, or government agents, human beings who claim to be going up there and doing it. So it could just be said that you're doing an extrapolation fallacy of extrapolating those physics as to at some point they would free fall around a sphere. Because what I would say is that in reality, the reason the Earth gets in the way is because down is down, and what goes up must come down. So it's going to end up hitting the ground. Whereas you're saying that this thing at 17,000 miles an hour never will hit the ground. It'll just keep arcing forever and looping back around itself, forever, essentially, without any additional propulsion. So, I mean, that's a whole different level of, it might be using some part of physics of throwing a baseball in terms of some of the math, and any good deception would use something in reality to then extrapolate it with a couple assumptions and get people to comb over it, and then they get them to believe in something that's false, even though they're an intelligent person. But there's just, they don't realize the assumptions are the clincher for thinking something is happening in physical reality that they can't confirm is actually physics.
Well, you can do a very good job of confirming the physics terrestrially, right? You can apply the orbital model to your projectile, and you'll get excellent predictions as to where your projectile's path will be and how far it will go. Then you can look at the extreme case, which is things that are already in orbit, and there's a huge amount of stuff you can do to validate that those things are actually where they are, traveling at the speed that they're saying. So, and what their path is as well. So, you might have to extrapolate to the broader case, but the evidence is there that the extrapolation works.
Well, let me take another extreme example. The Van de Graaff generator, where it has the two plates, and then you can charge it, and the little sheet of paper will go from the bottom plate and stick to the top plate.
Oh, yeah.
Now, I'm not even making this claim, but let's just say, as a hypothetical example, let's say somebody said, when you go up above a planar stationary Earth, when you go up there, at some point at the Kármán line, if they were to say that you would just start clinging upwards, like once you got to the 60 miles up, you would just start floating up and up, and you would cling to the ceiling. Let's just say somebody said that. And and they said, yeah, and maybe they have a bunch of pictures of it, and they have astronauts, clinging to the dome or whatever. So I'm just using that as like an extreme example. And if their proof of it was to say, well, hey, we can take telescopes, we can look, we can get signals, because I know that's what you're talking about, satellites. You can get signals to quote unquote confirm. That's really not confirming, because you're not actually able to confirm the physical machine that might maybe coming from. But I realize you can get signals and things, and you can see lights and so on. But if somebody were to do the same thing, there's astronauts up there, and and they're clinging up to the ceiling, and then their proof of that was to say a Van de Graaff generator, look, I can do it on this scale. I think you guys would all agree that's quite an extrapolation to extrapolate that the physics down on the ground of, look, you can do this Van de Graaff generator and the static charge, and you can get this thing to cling to the top plate. Therefore, there's a ceiling, and when you go up, once you get high enough up, you start to cling upwards. Again, I'm not making that argument. I'm just kind of giving like a generalized sense of how some of these things can be like it's kind of like this ad hoc. It's like part and parcel, like some physics that we experience, certain math, and then in my opinion, with the heliocentric one, there's certain assumptions along with things that you think you're confirming if you're getting like signals from satellite TV, and then therefore even though that isn't really confirming exactly what that equipment is and so on, just because you're getting the signal, which is a whole nother topic. And then extrapolating that to, into something that you're thinking is real physics. And I'm just saying, I think if you were really, 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 just intellectually honest with oneself, I'm not saying you personally, but you would actually be able to say, okay, well, I believe that's happening because of these other factors, but you don't really have proof that that's happening in the physical world. Like if you were, up, talking to God after you die or whatever, if, that kind of idea, and you were to be like, and God were to be like, did you really know that orbital thing was happening? And if it was between heaven and hell, I mean, I'm just using that dramatic kind of example, you would really have to be like, you know what? No, I don't really know that orbital thing. I extrapolated it from this, and that, and I thought it was, and I trusted the government and other people that were doing it. Like, would you be honest? That would have to be your position when it really boils down to it.
Well, that's the thing, right? So your example is an extreme, flip to the absurdity, right? And of which there is no evidence. And you said that yourself. It's something that has no evidence. It's just a make-up extreme example. But so in the scenario that I'm talking about, right, that I know that I can verify, first of all, the concept of free fall, zero acceleration, zero, the accelerometer will read zero during the projectile motion phase of the flight, the ballistic phase. And I can see that continuing as far as I can physically stretch my experimental things. And then I can go back and I can repeat things that have been done historically. So one of the things of which I find absolutely amazing was the amount of information that scientists were able to get out of the Sputnik satellite. So all that you could see from Sputnik was a little, white streak in the sky every now and then, and a radio beacon or two radio beacons. It just went beep, beep, beep at a constant speed. And just by listening to that beep as it went by from a couple of locations, they could work out where Sputnik was down to within about 2 or 3 meters. They had fantastic ability to precisely measure where Sputnik was, what its orbit was, and by looking at variations in that timing, they were able to determine a lot about the gravitational variations in Earth, information about its oblateness, and other things like that. So, and the Sputnik example is something that is within reach. It costs you about $500 to put together the kit to measure the Doppler of a satellite with a beacon, and the ISS has enough transmission at the right frequency that you don't need fancy gear to receive it. You could do the same with the ISS and determine, like Seafoam did optically, you can do that with radio as well, and actually determine the orbital path and position of the ISS at any given time, which gives you great confidence that the rest of your physics stacked up, right?
I could respond. I know I've been filling up some mic time as I've been responding. Was someone else trying to get in before when there's someone else?
I was just going to say that I'm more than happy to take the embrace the absurd position that we'll never know anything for sure, and everything is just varying degrees of reasonable guesses based on extrapolation off of our sensory info and trying to make sense of it in the most parsimonious way we can. But I was made fun of for taking that position previously by people on the other side who believe very strongly that there's some way to first principles ourself into knowing absolute truths about the universe. So just wanted to comment on that.
Yeah, no, I mean, reasonable
on,
guesses. Yeah. Reasonable guesses, is that the phrase you said?
Yeah, gradations of them, and when I die, I'll be able to say, like, look, I was making the best guess I could by what I knew.
No, I got you, and that's part of this conversation. It's kind of just, it's not as much about, somebody winning a debate right now. I'm just sort of asking questions. It's more about just, kind of what we can prove or validate, what actually is occurring in physics, and then how did we come to those conclusions. And then I'm kind of challenging this, in terms of the orbital effect, and then, how does one really conclude that this orbital effect is happening? Obviously, there could be belief, pictures from a government agency, or claims from other agencies. And I hear what you're saying. I mean, in life, you do have to, like, I've never been to China, but I do think China exists. Like, in that exact example of, like, oh, you die and there's some ultimate guy questioning you, and it's like, okay, does China exist? Like, I would go with yes, and I'm not even saying I believe in necessarily that the whole, like, God judging you after birth or after death. I'm just sort of making that as kind of a dramatic thing. Like, you could also say, like, gun to your head, do you really think, can you really prove orbital mechanics? Gun to your head, meaning if you're wrong, you would, get shot or whatever. And if you're right, you would, live. So you could use like an extreme example like that, the old like gun to your head kind of analogy. But yeah, it's just in terms of what actually is occurring. So I mean, you're agreeing that there's some leaps that you would have to take in terms of the orbital component of this.
As far as like, yeah, what would I do to try to confirm to myself the orbital model of things based purely on experiments I could do myself? I can't create an experiment in which I'm going to see one mass orbiting another, but it would be a set of extrapolations from what I could test in my lab of masses attracting each other, of general principles of circular motion, of general principles of the arc I see something taking when thrown through the air, and then extrapolated to like, yeah, like, what if it was arcing like that and the Earth was curving away from it at the same rate? And then, so I bring up the magnetic analogy of just like, okay, what else can we see about other forces of nature that are more immediately accessible to kind of individual exploration and experimentation on them in a tabletop setup, and can we try to reproduce some of these phenomenon in other setups, and be like, okay, if I can see the circular motion in this case, it makes it easier to imagine how a similar type of orbital circular motion could occur in a vastly different scale, and then that would be it. That would be as far as I could go in trying to make the case to myself that this is the most likely explanation of what the moon is doing up there.
No, I got you, but that's why I made the example of like the Van de Graaff generator. Again, I wasn't making that claim, but if someone were to say, hey, this little piece of paper will go from the bottom plate and then it'll float up to the top plate. And if someone were to say, it's a planar stationary Earth, and when you go up there, you start to cling to the ceiling. And then if they were to say, oh, the Van de Graaff generator is proof that you cling to the ceiling. And then maybe even if they had a lot of money and a lot of the whole military behind them and decades of world wars and genocides, maybe even that group could, if they really want to push that theory, they could have video of astronauts clinging to the ceiling. Maybe they could even have communication devices like satellite TVs that they claim are clung to a certain position on the ceiling. And hey, look, if you point your dish over here, you're pointing to this thing clung on the ceiling. But that whole thing could be an elaborate deception, meaning that things are not clinging to the ceiling. Maybe they just have communication devices up there. There could be some other way that they're pulling it off. And I know this does get into the conspiratorial side, but essentially that would be what would be going on. Like, if we're going to take the two extreme examples, number one, we're on a stationary planar Earth. There is no orbit in the way the globe model claims. There is no things going around a ball. There is motion in the sky. There might even be another effect. Some people have theories like maybe the ether is actually like almost like a flow of liquid or something, and you can shoot something up into it and it'll actually loop around up there. Like, there's other kinds of ideas. But if it's not the orbital one around the globe, then yes, it would have to be that there would be some level of an elaborate deception here, like a magic trick, where they are replicating some of the positionings. And we've talked about like spoofing GPS or like spoofing signals using spoofing techniques and so on, to where almost like if you were at I'll finish on this. If you were at like a magic show and the magician was doing things, and you might be able to even confirm some of it, like maybe you could even have some equipment or a spectroscopy device or something in the crowd where you could be saying like, oh yeah, he really is making those things float, or he is making those things stick to the ceiling. I can bounce radio waves off of them, even though the whole thing is a magic trick. So, that is kind of, that's why I'm kind of asking like, what can we know versus what do we have to believe? And then, getting to the truth in terms of all that without, taking any leaps in logic, just the kind of quest of that,
Well, with the Van de Graaff generator, like, I've never myself personally encountered a electric field so strong that it lifted my entire body up and stuck it to something. But yeah, I totally would extrapolate that would happen based on my small scale experiments with a piece of paper and a Van de Graaff generator. So sure, like, yeah, that's the same type of extrapolation. I see this thing happening to a little object. I imagine that if there was a large enough Van de Graaff generator generating enough force, it would do something like that to a larger object like myself, of course. Now, I think the main issue with that thought experiment is I don't see a gigantic metal plate over my head in the sky. Um, every Van de Graaff generator I've ever worked with is metallic, and the sky seems to be very transparent. So um, I take the general point to it, right? But I guess what I'm wondering is, in your sort of thought experiment here, like, how seriously should I be taking the idea that there's some massive electrostatic metal plate above my head if I now also have to work into this? Okay, but it's not going to be made of any material that's anything like the Van de Graaff generator I've got on my tabletop. I now have to imagine it's totally transparent and made of something completely different, that I've never experienced before. It's the dome or whatever. I don't mean to be getting us off topic from your main point there,
Could I?
but it just feels like the orbital thing's an easier extrapolation because I can look at the motion of the lights in the sky, in an amateur telescope, moving through what looks to me like empty space on paths that I can track.
No, I hear you. I think the Van de Graaff generator was just kind of an extreme example of if somebody said that, like, hey, I can replicate it on a small scale. And then they had this whole theory that if you go up 60 miles or higher, that all of a sudden you'll cling to the ceiling. It was just kind of like a hypothetical example. I wasn't making the argument. I mean, technically, the sky, I hear what you're saying, if it doesn't look like metal, but it could be like a conductive glass material, or even, somebody could make a theory and say that it's conductive or that it's made of metal and it just happens to look like that. But I was just more using the example of, like, if somebody made a dramatic physics claim that if you go up high enough, you start clinging upwards, and then the reason was a Van de Graaff, like, to me, that would still be a leap. Like, they could have a theory of that or have some theoretical thing. But and then to take that example further, if there was a whole government agency that wanted to convince people of that for some reason, and let's say it was actually false, but they wanted to convince them, they might be able to, concoct a very elaborate type of story, even with videos from astronauts clinging to it, or the communication devices seemingly being clung to different parts of the ceiling. And if I point it to, they tell me that it's clung to that part of the dome, and if I point my satellite dish, I'll get the signal. But if I don't point it right at that part of the sky, I don't get the signal. Therefore, the thing's clinging up to the ceiling, even though the thing might not be clinging up to the ceiling, it might be something else, a whole other technology. So that was I just brought it up as kind of just an example, that would also involve various assumptions, because what's being claimed with the orbital effect is that it really can't be replicated on Earth, that you have to go 17,000 miles an hour and start orbiting around the Earth itself, in order for that effect for that physics to be seen or claimed to be happening. And so that's the thing where it's like, it takes that. And I'm also willing to be charitable to that position. I understand that is the claim that, the Earth is very large. It's the only thing that has that much mass in order to create that effect, to where normally we throw something that's just going to fall to the ground. But the claim is that the globe is so large, and the size and the mass and everything, that you have to get to that 17,000 miles an hour. So I realize that's part of it. A lot of people would say that's unfalsifiable, but it is kind of a scaling factor that, you'd have to be large enough. But even if someone made the example of the Van de Graaff generator and said, you have to be up high enough, and all of a sudden you cling up there because the mass of the Earth has to be, you have to reach that midpoint of the mass of the sky, mass of the Earth. Again, I'm just making up that theory, but I mean, if somebody were to do that, they'd be extrapolating a whole thing around it, and it's kind of at a breaking point in the sky that we can't confirm, and then you have to go with these other authorities, that physics is actually happening.
Yeah, I mean, I think in that example, I don't really have any issue at all, or see anything absurd with the extrapolation of, like, things stick to small electrically charged surfaces. So if there were a very large one, things would stick to it too, right? Then I'd be looking just for some more observational claims of the existence of such a surface, right, above us here, because I don't see things like, I don't see the things above me seemingly sticking in place. I do see them moving on arcs. So then the question is, can we match those arcs to an orbital model that in some way we can understand via a set of extrapolations from smaller laboratory scale things that don't quite reproduce the entire orbit but demonstrate different features of it that would go into explaining an orbit that could explain the observation of the actually seen in our own telescopes arcs that things make. But I guess I'm not trying to argue against the idea that with enough time and energy, deceptions are possible. I don't know. Someone has
Oh,
anything
ZZ, I
else?
was gonna ask you, what do you think of Newton's bucket experiment?
Well, it demonstrates that rotational motion is not relative. That there is a difference between the bucket that's not rotating and the bucket that is rotating.
Right. So you would say it's stationary Earth is the preferred inertial frame in regards to rotation?
Well, I mean, then the question is stationary Earth the only inertial frame, right? That's why I was interested in bringing up, do you see the same thing in the spinning bucket on a train that's moving at constant velocity, right?
Right,
'Cause the
but one's
spinning bucket,
measuring for linear motion and then Newton's bucket is rotation.
yeah, Newton's bucket's measuring for rotational motion, not linear motion, and it shows there's a
Right.
difference between zero rotational motion and having rotational motion. Like it shows that rotational motion is something that is intrinsically real within a system. It's not relative. Even if you were spinning with the bucket and it didn't look like the bucket was spinning from your perspective, you would still see the curving of the water within the bucket, which would show that something's happening there.
Right.
So yeah, no, and that's very true. Rotational motion is non-relative, and then you can get into some very deep questions about well, why isn't it? But just to address some of the stuff that Alan was talking about, the mainstream consensus is not that all motion is relative; it's that specifically constant linear motion is relative. So it is a bit of a straw man argument to say that oh, physics says all motion is relative, but look at the bucket example. It's no. The mainstream thing is very specific. It's just saying that constant linear motion is the thing that's relative. But mainstream physics would absolutely say that acceleration and rotation are not relative, that there are ways to directly measure them and know the difference between them and being inertial.
Are we ever going to get anti-gravity technology, dude?
Are we ever going to get anti-gravity technology? I don't know. That'd be cool. I'm not aware of any path to it. I'm skeptical about it existing.
So you would expect Newton's bucket to be the exact same on
the train? Yeah.
Airplane or a train as it would on the ground?
Yep. I'm willing to bet on that. If anyone wants to put that together.
Wouldn't you have to factor for the turbulence though, which is impossible?
Yeah. So,
but wait, but how is that not evidence of a stationary Earth in regards to rotation? Yeah.
Well, then people would say, okay, well, the rotation of the Earth is not. It does create some correction, some alteration to it, as to what you would see if you did Newton's bucket. In a more even ideal situation here, but it's just that the rotation of the Earth has a negligible effect on the bucket. But you're right. Where I was going to get back to that.
In fact,
get back to that point
real quick.
Sorry, go on.
Yeah, I just want to say, I believe when they do rotating liquid mirrors, that they actually they tip a little bit based on which direction they're rotating because of Earth's rotation. They're basically a Newton's bucket, but they form a telescope mirror out of rotating Mercury or something. But there's a gyroscope effect.
Yeah, but here's an important point. Within the spinning Earth model, same thing would be true on the train as well. So the real question here is not whether or not the motion of the Earth in some small way factors into what we see in the bucket, but can the bucket distinguish between being on the ground on the Earth versus being on a train on the Earth? So that's where I'm placing my bets. That smooth train ride on the surface of the Earth, the bucket will not distinguish between being on the train versus being on solid ground.
So the only way it would be able to is because of if the train was going really fast and level, that will be an angular change, equating to 15 degrees per hour at 1,000 miles an hour.
Yeah.
Which
Okay,
would gyroscope the Newton's bucket a little bit.
how do you guys think it would perform on like a rotating platform? So like the spinning bucket on a rotating platform.
Badly.
You could measure your absolute rotational velocity using the bucket. And your distance from the center of the platform.
Yeah.
Right. Well, if you were on the rotating platform looking at the bucket versus, an observer standing on stationary Earth is going to be different. Because stationary Earth is the preferred inertial frame. It's the only frame in which physics directly applies in regards to rotation.
Well, no, that's what we were talking about. Is if it works out the same on the train, then the train's an equally good frame for describing physics.
All right, but train is linear motion. That's like it's kind of a non sequitur. We're talking about rotational.
Yeah, so the whole question is, does the linear motion of the train in any way affect the rotational motion of the bucket?
I don't think it would. Right. I was talking about the rotational.
Yeah, but then that supports what I was saying here, that if the linear motion of the train does not affect anything about the rotational motion of the bucket, then the bucket
Right, that's
is
not in
showing.
contention. I have no contention with that.
Yeah. And
My
the bucket
whole
is showing.
point is that's evidence for a stationary Earth. If that's the only frame in which physics directly applies in regards to rotation, that's evidence of a stationary Earth.
The
Well, it's
bucket
evidence
works
of.
just about
He's
anywhere you can
right.
imagine.
Well, I was going to say it's evidence for a difference between rotation and non-rotation. But it's not picking out the Earth as a preferable frame to the train if it works just as well in both cases.
And it's just a thought experiment, right? That you couldn't. So, given the Earth is, by other means, a measurably rotating reference frame, the bucket itself breaks down as a real experiment because it's basically a thought experiment. And unless you had extreme rotation, other than what the scenario that Jesse's kind of describing, it's just about impossible to make the Newton's buckets precise enough to determine whether or not it is also in a rotating reference frame.
No, Newton's bucket is like pretty much agreed on mainstream consensus, what it shows.
So what would you expect the Newton's bucket to do in free fall if we drop the Newton's bucket? So you're talking about the bucket where you just spin the bucket and the water spins up to speed with the bucket around its axis. Is that the bucket experiment?
Yeah, just fill up a bucket with water and tie it to a rope and spin it.
So what would you expect to see in free fall? Oh, no, tied. Yeah, spin it hanging from a rope. Yeah. So if you're in free fall with a spinning bucket, what would you expect to see?
I mean, that's a good question.
An empty bucket.
Yeah, that's what I was thinking.
Newton's empty bucket.
Yeah, that's it. You need to put a lid on it because the water would form a cylinder and flow out the ends, right?
Right.
So Newton's bucket is actually evidence of gravity and rotation of the bucket, and that's it.
Okay. So yeah, I don't know. I interpret that as evidence for a stationary.
So why? Well, the bucket would, as the other guy was saying, the bucket would work the same on a train, going in any arbitrary direction. So why would those reference frames be different to the Earth? They're clearly in motion compared to the Earth. The bucket still behaves the same. So the Earth is not the preferred
that's what
frame.
I'm
It could be
asking.
a train.
Yeah, I don't have any problem with linear motion not affecting it, because Newton's bucket was not designed to look at linear motion. It was designed to test rotational motion. So
Yeah, just designed to test whether
looking
the
at
bucket.
linear motion is like, non sequitur.
Okay, and if Newton's bucket were to detect Earth rotation, what would that be like? What would it do differently?
If Newton's bucket were to detect Earth rotation, I think that's
Yes.
kind of malformed.
Not at all.
Can you clarify? Or
Certainly. Is it your claim that Newton's bucket was designed to detect Earth's rotation?
no, it was designed to test relative and absolute motion or rotational motion.
You mean about the axis of the bucket or some other axis?
The axis of the bucket or some other axis? I'm not sure what you mean. It's designed to look at how we would predict the water to behave, on the stationary Earth observer versus the bucketeer, the person, who's riding on the spinning bucket. What do they see? Or what they predict to see the water behave like versus the, stationary Earth observer.
Okay, so what would Newton's bucket do differently if Earth was a globe, or would it do nothing differently?
Well, that's what I was asking about the rotational platform, right? If we have it on a rotating platform, how would it behave? You guys said it would behave all erratically, which I said I probably agree with that because the stationary Earth frame is the only inertial frame. So, I would predict the rotational frame to have problems and the stationary Earth to, predict reliably with direct forces.
Yep, can't rule it out. You could just have a philosophical preference. That's the best thing you could have. It's a shame.
I'd say it even leans in the stationary Earth direction because that's the only frame in which the physics directly apply without pseudo forces or, any extra forces.
Or ad hoc explanations.
Right?
Physics,
Right?
Your natural experience.
Physics tells us that all inertial reference frames are equivalent. So the train is another inertial frame. You can be flying. Compared to the Earth, these things are inertial frames, right? If we consider the Earth an inertial or approximately inertial reference frame,
You said all inertial frames? You said
there's
all
no
inertial?
Yeah. So if you consider the Earth to be inertial, an inertial reference, then any frame traveling at constant velocity relative to the surface of the Earth is also an inertial reference frame, which
Even
in itself
in
says there's
regards to
no.
rotation.
No, so we're assuming that the Earth is not rotating now, right? And it is a perfect inertial reference frame, which it's not, but we'll assume it. That means that any other reference frame that's traveling at constant velocity relative to your reference on Earth is also an inertial reference frame, which means the Earth is not the preferred reference because any of those others will work just as well without any extra forces being introduced.
That's the whole thing Newton's bucket challenges, right?
No,
Because
Newton's bucket.
you'd expect the bucketeer to have the same or have a valid prediction just as the stationary Earth observer does, but that's just not what we see in reality.
No,
So that's
the
the whole
bucket.
point. It challenges that, claim that you're making.
The bucket on the train will behave exactly as the bucket on the stationary
Right,
Earth
and
does.
that's not in contention. That's it's a category error, honestly.
So what
You're
precisely
talking
are
about a
you
linear
saying?
motion test. Newton's bucket is a rotational motion test.
It's a test of the rotation of the water in the bucket. That is all. So it's talking about what is happening to the water.
The test of which frame directly predicts, or correctly makes the correct prediction, right? Which frame predicts that,
They
and
all,
the answer is the stationary Earth frame.
I mean, they all predict the same thing. You do the math.
No, they don't. If you're riding on the bucket, the bucket's here, and you're going the same speed as the water, you're co-rotating with the water, you would predict flat water, right? But that's not what we see.
We're all in
We see
agreement that the bucket
water.
feels
Right.
rotation, but the bucket gives you a way of observing the effects of rotation even if you are rotating with the bucket. The question was, is there anything about the bucket that can be used to detect other forms of motion, like constant linear motion? And the answer there is no.
Yeah, I wouldn't say it's a detector. It's not really a detector. It's a test of the frames, seeing which frame is more viable, right?
But we weren't discussing between the Earth frame versus the bucketeer who's spinning with the bucket. We were talking about the train frame, someone who's on the train and the train's just going in a straight line.
Yeah, but you guys brought that up, and I just pointed out how it's kind of a non sequitur. It's
scope of frames and space and such that people are
Okay.
interested in delving
If
into.
we want to go to reference frames, though, I do have one question for you. If your claim is that the Earth is stationary and not rotating at all, what explains Coriolis?
what explains core. So, what is your claim dynamic? What is it? The motion of
My
the
claim
relative
dynamic
motion of Earth in the cosmos?
No, Coriolis is the spin of the Earth.
Right. So it's relative motion of the Earth moving through the cosmos.
Sure. Yeah, you could. Yeah, actually, no, that is fair.
Okay, I could just. Yeah, it's an unfalsifiable claim. I could just claim that it's due to the motion of the cosmos moving around a fixed Earth. Mach's
But
principle.
again, the way you deal with it is your Newton's bucket experiment. Like, I'm going to use your own experiment here. If you are in an inertial frame, like if the Earth is actually inertial, and there should be no rotation forces that come up at any point. And the rotation forces are weak because the Earth is not rotating very fast. But they do exist. They are measurable. And if we can measure rotation forces, that means the Earth is not inertial.
Okay, right. You're attributing it to Earth moving through the sky. I would attribute it to the whole entire sky, the entire cosmos rotating around and moving around a fixed Earth.
But even if that's true, Earth is still not inertial. Even if your theory is right. Like, the explanation
I
is
don't
not
think Earth is
testable.
in motion.
The data is testable. We can test that
I
the
see
Earth
the
is
sky move. I see things in the sky move around me. I never see Earth move. So,
Okay,
in
but
my view,
again,
my option is more viable.
Whatever philosophical explanation you want to give for it, we can test whether Earth is inertial, and it is not. There are forces.
Stationary Earth. It's the only reference frame
It's
in
not
which the
inertial.
laws of physics directly apply in regards to rotation.
It's not. That's why
You guys
Coriolis.
just agreed on this. zzpop just agreed on it. It's evidence
No,
for stationary Earth.
we agreed on it for the sake of the hypothetical. We didn't agree that it was literally true.
No, literally everyone agrees. Mainstream agrees. That's why zzpop's not disagreeing.
No, I just said that the effects of like Coriolis and stuff on Newton's bucket were negligible for the purpose of what we were talking about. And my only main point was just that if we do or do not account for things like Coriolis, I was just saying that if anyone would like to go do this and film it, that I'm betting on the bucket being the same on the train as it was on the ground.
I would agree with you. That's not really my point. I don't think anyone would disagree.
But we can test whether Earth is inertial, and it's not.
Come on, bro.
What? Like,
What?
it's an easy.
You guys keep making me repeat myself. I sound like a broken record over here. It's crazy.
I mean, you're making me repeat myself too. That's how these debates always go.
Okay.
But we can test whether it's inertial. Now, if your claim is Earth is non-inertial reference frame because the sky is rotating, that is consistent with this observation. It's more of a philosophical difference than a testable difference. But You can't deny that the Earth is not inertial. It is clearly not inertial.
Oh, I keep saying my claim. I guess you want me to repeat it again. But the stationary Earth frame is the only frame in which the laws of physics directly apply in regards to rotation. For the stationary Earth frame is the preferred inertial frame.
It's not inertial.
Bullshit.
But you guys just agree. You guys just agreed that's the case, or ZZ Top did.
We agreed that the hypothetical it wasn't relevant to.
No,
We
no,
did not
this is
agree
Newton's
that-
bucket experiment. You can do this at your house.
Okay, I don't have equipment sensitive enough to measure the effects of Earth's rotation on a bucket of water. But it's not inertial.
You don't need to. That's not the experiment.
It would be.
You need to see which frame makes the correct prediction.
Okay. The stationary with respect
I
to the
know.
cosmos frame and the stationary with respect to the Earth frame. I don't have the equipment to tell them apart.
Okay, I'll give you a hint. The only frame that correctly predicts the rotation of the water is the stationary Earth frame.
Oh. I don't have a bucket big enough to
Can't
test
argue against this, bro.
I
It's just
can, and I
mainstream
will.
consensus. So
can,
now
and I will.
you're going off into uncharted territory now.
No, it's not uncharted at all. I'm going to give you some experiments that are you can do to test it, but it won't be a bucket of water.
You can't.
You test rotation with respect to the stars versus testing for it with respect to the Earth. Stars frame gives more accurate predictions. You can't tell the difference with the bucket of water. You need other equipment. Foucault's pendulum is the classic. But if you use Foucault's pendulum, stationary with respect to the stars gives better predictions than stationary with respect to the Earth.
Yeah, but that's on a stationary Earth. So
I didn't say it was a stationary Earth. I said it was stationary stars.
stationary stars? You said they were moving.
I said that your claim was that they were moving. I did not claim myself.
My bad. My bad.
Fair. If you treat the stars as stationary and do your physics with that, you will get more accurate results than if you treat the Earth as stationary.
Okay.
So then
I disagree.
Not,
what would be more accurate, and what would be more accurate?
Yeah, the easy experiment here is Foucault's pendulum. There would be no reason for it to drift on a stationary Earth. There is on a rotating
Foucault's pendulum.
and it drifts.
Wait, what? Say it again.
Are you familiar with Foucault's pendulum?
Yeah.
Yeah, that one. It would not drift if the Earth was stationary. It does drift.
What? So you're attributing the effects to Earth spinning?
I think that's my preferred explanation, but
Okay, well, any effects you attribute to the motion of Earth, we can just equally attribute to the rotation and the movement of the cosmos around a stationary Earth. All right, so you can make unfalsifiable claim, and we can make unfalsifiable claim as to the dynamic, right?
I'm not making
it doesn't have to fit your definition of gravity. The theories that go along with that, the baggage, doesn't need to be included.
Whatever you want to call it. It is consistent with the measurement, or like with the predictions made by the globe rotating once a week.
Is it just moving straight without rotating?
Newton's bucket would be evidence that the Earth is stationary or moving straight. The only thing it shows
or just moving straight, but just moving straight would break everything.
No, it doesn't.
But also,
Why would you say that?
ZZ, I think you're kind of missing the point, though, because the thing is, we do have a Newton's bucket experiment that does prove the Earth is rotating. It just, you need a bunch of
and then
the size of the Earth.
Wait, what's that one? What's that one?
Well, the size of the Earth. Measure gravity at the equator versus the pole. There's a difference of about 1/3%, which is what the Newton's bucket experiment would predict for the Earth's rotation, like the speed it rotates at.
No,
that's with a bunch of assumptions about what gravity is, but yeah.
Yeah, I mean, the bucket would effectively, at that scale, the bucket effectively acts as gravity is weaker or stronger. Yeah. And if you measure gravity,
which could be an electromagnetic effect or whatever it is. It doesn't have to fit your definition of gravity. The theories that go along with that, the baggage, doesn't need to be included.
Whatever you want to call it. It is consistent with the measurement, or like with the predictions made by the globe rotating once a day.
Never isolated a cause.
I didn't say I had isolated cause. I just said it's consistent with.
Bucket on the Earth, you would get the effects of, that you get, and then the one in the spaceship the water would fly all over the ship.
Well, I mean, that's the flaw of the bucket, because it requires gravity to keep the water in the bucket. But there are alternatives that will test the same thing that the rotating bucket's trying to test, but don't have the problem of the water, splashing out. Look, I mean, being in the star's reference frame isn't tracking its motion. Doesn't mean I'm experiencing the temperature of being right up against those stars. So yeah, of course, if there's something that is dependent on being in contact with something, that it matters if you're in contact with it. But
isn't that the whole point of this? Is that it's the spinning of the bucket when you're in the frame? Isn't that the whole contention?
I mean, okay, replace the bucket with like a ring laser gyro or something that doesn't require gravity. It's going to be the same effect, same result. Just Newton didn't know about ring laser gyros because it hadn't been invented yet.
But obviously, the water in the bucket does involve, if you want to call it gravity, but whether it's convex, concave, flat, there's going to be centrifugal. There's going to be the forces involved, and so that's a factor of what's actually being discussed is the physics of the reference frame, and relating the physics of what's happening with the bucket to the frame, whether the frame is stationary, meaning it doesn't have there's no plus or negative, it's just even, and then the bucket does what it does, rather than if you're in a frame that's in motion, in which you would have to factor that motion in. So that's what's in contention. So you would need to be in the frame physically with those physics to try to claim there's some other frame that would equate, that would be equally predictable. You'd have to be in that other frame and test it, and then show that some other frame that's in motion, in relation to another, is giving the same results.
Saying that, well, it could be other things. Well, then there's a lot of unknown forces which needs to work in different ways to conform to what we actually observe and measure.
Like dark matter.
I'll give you a flat Earth affirming the consequent. Right?
And honestly, dark matter is a case where proper science is at the edge. It doesn't know the answer. And if you want to look at dark matter and say, no, that doesn't make sense to me, I don't like it, that's fine. But the thing is, everything in the solar system, there's no dark matter equivalent. There's nothing where we're uncertain of it.
All right, hold on. I just
crazy level of detail inside the solar system, and everything has worked properly. So
hold on. You did interrupt Beast though. I just said dark matter because what he was saying is precisely what dark matter is sort of said to be, and he was trying to say as if that's like a criticism of you'd have to make up this matter that I'm just saying this is what they did with dark matter. But I wasn't trying to derail them. Can we let Beast finish what he was saying?
I'm agreeing with you. So
I was just trying to extend an olive branch. I'm not just going to say, oh, that's affirming the consequent and not giving you an example. For example, flat Earth affirming the consequent would be to say that if I measured 2 miles to have no curvature, then that means that would be a parts of the whole fallacy. So by you only measuring the precession at certain latitudes, and not actually isolating the cause or the independent variable, you can't say that moving the latitude is your independent variable, because then what you would be saying is the latitude change or the latitudinal change is what is the cause now.
No, it causes the change in the dependent variable, which is true. Again, you're confusing.
What's the dependent variable?
The dependent variable is the rate of precession.
Okay, you have a rate of precession, and what causes the rate of precession?
Now we found a link between latitude and rate of precession.
Yeah,
you vary the latitude, you get different rates of precession.
Yeah, he's confusing again. Hold on. You have to clearly understand this. You're confusing the hypothesis with the experiment. They're two separate. That always happens for some reason. This dependent variable, independent variable thing always seems to get clouded together. They're very separate.
Yeah, only with globe proofs. Yeah.
No. It's the science. It's gotta make sense. Like when I say time is an independent variable. Well, you think time caused that? No, time caused the change in this particular experiment, but the overall independent variable relationship in the experiment is far different than me talking about what causes. If I say the reason that the focal pendulum spins is because the Earth rotates, and then get into the description of how that actually works, and then we do an experiment, and we changed the latitude, and it did change the rate of precession. I'm not saying that the latitude change is what's causing the precession. That because I'm using your context of the word cause. If you
Well, then it
notice
can't
that.
be an independent variable because the
No.
independent variable is the cause.
Okay, so
Exactly.
you're doing
No.
you're doing it also. Gio, you're doing it also.
Yeah,
There's
the
a
independent
cause.
variable is the
You're
thing that
doing it wrong
changed.
too, Gio. You're doing it wrong. You're doing it
You
wrong,
are no,
Gio.
you are. It's really simple, and I think Gio of all people will be able to get this real quick. So if I say
Dude,
cause and
the
hold on, let me
independent
just,
variable causes a change in the dependent variable.
yes,
And
yes,
the
you're not
independent
wrong.
variable is the thing that causes, like in chemistry, you put a chemical in and it
You don't
changes
think I know
everything. That's
this?
the cause.
I know this, and
Oh.
I know you know this, but let me just finish the sentence because I think you're just not listening
No,
real quick.
Zanick, we don't need you to
I,
preach
I, I
about
do.
why
Just
it's not
let
affirming the
let me
consequence.
finish the
It's affirming
sentence.
the
You might get
consequence.
it. I mean, let me get one last try, Gio. Can you indulge me one last try at this? It'd be less than 10 seconds. Promise.
One last try to what?
Let me try to explain because you keep on. We all understand you're conflating it and confusing it, and you don't.
Not
So let me just
conflating it,
try.
not confusing it, just
Let me try
explaining
it. Let me.
that it's
It'd
not
be
an
over by now.
actual
You're
cause.
wasting time. Stop it. So we have a hypothesis with a cause and effect relationship. That cause and effect relationship is not the same as the experiments you create to support the hypothesis. So the word cause and effect are the same words, but the context is different. So real quick example, a hypothesis. I think that this Foucault pendulum, be real brief here by the way, Foucault pendulum will precess if it's placed in different latitudes because the Earth rotates. And I'll have a model and I'll show how this works. Oh, that makes sense. And we all see the diagrams. Then I go do a test of the hypothesis, which is an experiment. Now that cause and effect relationship is completely different. I move the latitude position and I see that the precession rate changed. That is a valid experiment. That is a cause and effect relationship. That's an independent dependent variable change.
The cause
But
of
it
the
has no,
precession
oh,
is the
let
latitude
me.
change.
I
You
almost,
said it again.
I almost had it out. That is not related to the cause and effect relationship of the hypothesis. Even the word is the same. They're talking about something different. Does that make sense?
Hey, could I ask you a couple of questions, Zanick? They're yes or no's.
Well, I'd like to hear his. I asked the question whether it made sense or not, but because I really wanted both Gio and this gentleman to understand that
It
the
makes sense what
hypothesis,
you believe,
cause and
Zanick.
effect is not. There's not an independent dependent in a hypothesis. That's only in the experiment.
I'm curious about what Galley's questions are, though.
But
If
I
you're willing
wanted
to
you to answer
entertain
whether
Zanick.
do you get my point? I mean, whether I'm right or
I
wrong,
do.
do you understand what I'm saying?
Yeah, I know.
Can you
Whether
steal,
you're right or
can you steal
wrong,
man what? Can you steal man what I said?
I understand where you're coming from.
Can
I
you steal man
understand.
what I said?
Yeah, it's still
It
affirming
was
the
it was
consequence.
very disjointed though. It was kind of
It's
all over
not.
the
It's
place.
not. It's very clear.
It
Very
was
clear.
Nah.
not clear at all.
I could show you how to make a very clear argument if you let me ask you a couple of questions.
Oh yeah, I definitely want to hear that, but I did want to see if you could.
Your argument was that it looks similar, it's using the same words, it's performing the same function, but it's actually not what we think it is. That
Yeah,
was
but
your
cause
pretty
means
much.
They
something
don't
else,
look
effect means
similar.
something else.
You almost had it right.
all.
They don't
All
look
right, Zen, if we
similar.
let you go on,
They're
brother,
different. Okay.
let
I just
Galley
want
ask his
I wanted to
questions.
get it out, and I hope. Thank you for letting me do that. But hopefully that helped.
You're welcome. Go ahead, Galley.
Zanick, do you agree that empirical evidence refers to evidence gathered through direct observation or experimentation rather than relying on theory or speculation?
Yes.
Do you agree that in scientific experimentation, you must have the independent variable, the thing you change, the cause, and the dependent variable, the thing you measure, the effect?
Yes. Absolutely.
Okay. If you don't change
I
the
won't agree with that.
independent If you don't change the independent variable yourself, you're only observing a correlation, not testing causation. Manipulating the cause allows you to control for other variables and see if your change actually produces an effect.
That's nice. It's not required.
Yeah. So you're.
Well, I wasn't
from
asking you, I was asking Zanick, and then
Yeah.
giving a
Also
conclusion.
not required. Again, you're talking about the cause. The cause in the experiment will be completely something different. Even the word cause is the same in both terms or both segments of this what we're looking at
Okay,
here.
then you're equivocating the word cause
No, we're providing
so that way
evidence.
you can dismiss
No, all the cause.
people's
I'm not.
valid critique of your equivocation.
No, because we all agree that a change in an
Are you
independent.
using the word cause in two different ways?
No, we're not using it in two different ways. They're two different contexts.
Well, there's the word
You're
cause and there's the
using
word
the word
be
cause in
cause.
two different ways
Both cause
to
means the
try to
same in both instances.
invalidate people's
Okay.
critique of your
Oh my God,
claim.
you're straw manning me to an nth degree.
Stop talking through me.
Because you're not letting me answer. You've made your statement.
Here's the issue. You just ramble on with like Adderall riddled buzzwords, and
They're
it's
not
very hard
Adderall
for anyone to
riddled
give a coherent
buzzwords.
point when you repeatedly interrupt them.
Zanick, we've actually been going good for hours without like any modding being needed. So can we just keep with that and not have to go into any of that?
Well, just let me know when I can answer you. I mean, you're making a point. I still see an error in your logic, in your interpretation of what I said, but I'd like to respond to that. But go ahead.
Patience, patience.
I'm waiting. I know I'm paused indefinitely for him to respond.
Yeah, you're equivocating the word cause. You're using it in two different senses, so that way you can dismiss Geo and Beast's valid critique of how you're not manipulating an independent variable.
Okay, let me respond. So the word cause has the same application for both those situations. The situations are different though, because one is the hypothesis where you're saying we have a cause and effect. Cause and effect, not independent dependent variable relationship, which is used in the experimentation phase. The experimentation phase is different than the cause and effect relationship in the hypothesis. For example, we can't change gravity, but we can test for it by doing certain things that show a change in an independent variable acting on the dependent variable, which is in the test itself. Even things as simple as growing a plant. We can't.
Can I jump in? Before we jump on to other things, can I just jump in briefly? Okay, so that's fine in terms of using the word cause in different contexts of a hypothesis versus the actual experiment. Can I just ask you then, is there an independent variable in the Foucault's pendulum claim? And if so, what is that independent variable?
Latitude.
Okay, so now it's latitude.
It was latitude. That's what we started off with.
And latitude is the cause, bro.
So that is your independent variable, which is the cause. Even if you have this other thing of the hypothesis usage of the word cause, I understand that there might be something, does this cause that in the hypothesis? But now we're jumping to the independent variable part of it. So it was what you were saying was the independent variable is the latitude. That was it the whole time.
In the experiment,
That's the cause. So the cause is latitude.
What the independent
That's
variable
why we say it's a faulty
is
experiment.
you make a change in the independent variable and see if it affects the dependent variable. If it does, then that is the cause of that change. It doesn't mean
so the cause is latitude.
No, but that's in that experiment.
Not Earth rotation. Latitude change.
No. See, you're doing it. You're doing it what they were doing. No, Geo, I can't be more clear. That is
being
not
reasonable
part of the hypothesis.
scientific method. Yeah.
The independent variable
I'm
is
very
the cause.
familiar with
Okay,
the
let's
scientific
start
method.
with that. Do you agree that the independent variable is the cause in a scientific experiment?
Yes.
No.
Okay, and
Well,
you just
semantic.
said that the independent variable in this is your latitude. So that is the cause. Is that what you're saying?
I'm saying that independent variable change makes a change in a dependent variable. That's what it means.
So it's the
That's
cause?
So it's the cause.
It's the experimental cause. Let's say that.
Yeah. You know what else? You know what else is the cause? I can wait an hour and see how far it processes. That's hold on. That's a very important point because you can't really throw that back at me. I can see why you're still confused on the first thing, but
No
this
one's
one you're not.
confused, Andy.
No
Hold
one's
on.
confused.
Well, you kind of are. So if I say time,
No, we're not. You are.
Hold on. I have time is the independent variable which I'm going to change. I'm going to allow an hour to elapse, and then I'm going to take a measurement to see what changed. And if that precession rate had changed a certain distance or a certain angle, then I'll say that time was the cause of that change. Also valid, just as valid as my
Earth rotation. Okay.
So time and latitude are what your causes are, not the rotation of Earth.
I can do all.
The hypothesis is why those things affect the results of the experiment.
Our hypothesis is
But
the
for the
prediction.
experiment, like hypothetically,
The experiment is its prediction test.
Okay, hypothetically, if Cube Earth had a theory that latitude was secretly, how many gremlins were pushing on you, and that affected the results of the experiment. then you can show that there's a relationship between latitude and the precession rate with Foucault's pendulum. You cannot prove whether it's Earth's rotation or gremlin frequency that's doing it.
Exactly. That's the point.
I'm being entirely ridiculous here for a reason. So I agree that one could, in principle, come up with another explanation for these experimental results. Flat Earth hasn't done that because you guys are allergic to actually having theories that are testable. But in theory, it's
Tuco fallacy, bro.
Yep,
Look,
that's super okay.
You just admitted it, though, right?
I mean,
that you could imply any other type of cause because what you're talking about with this latitude thing,
when you guys
you're just
do
making a
it-
correlation. That's Galley's point. It's not an
But-
actual experiment where you're
But
controlling the human.
showing that there is a correlation is a valid experiment. That's most experiments in practice. You use indirect things. You do these sort of things because you need to for a lot of experimental processes. There's nothing wrong with
Right, but equating causation and correlation is a giant problem. And that's what's going on here. You have a bunch of different
Correlation-
data points that correlate by, I mean, I guess you're taking the side of Zanick in the argument. You have data points that correlate, and then you're just stating that they're a cause, but they're not.
No,
You
there's
have
actually
correlation
logic
at
behind.
best.
I do try to be precise with my language here because this is a point you guys make that has some validity. I cannot prove a cause. I cannot prove anything with science. All I can do is say we have this theory, we've tested it 1 billion times, it's worked every time. That's a damn good theory. Maybe something will come along tomorrow to change it, to prove it wrong. That hasn't happened yet.
Okay,
Well,
so
theory
this
can
is
test
sort
all
of
the
like
law.
platitudes, right? I could read that in a magazine.
But like, okay,
So,
if
like,
no other theory,
is
but no, if no
causation
other theory even comes
correlation?
close,
I
then
mean,
that
like,
means it's the best
Hold on,
theory.
wait. Why are you interrupting him?
autobiography, though. So is
You were done.
causation correlation, and is correlation causation?
They
Okay, great.
are separate
So
things,
then, okay,
but-
great. So then latitude is not the independent variable.
Yes, it is, because it's the thing you're varying in the experiment.
If it's the independent variable, then that's the cause, you guys. Come
No.
on.
No, hang on a minute.
Only in the
Hang
experiment,
on.
guys. Only in the experiment. What is
Yeah,
so
but
You know, the thing that matters, yeah.
Oh my gosh.
It's
All right,
not
I
the
figured it out. If we
change.
just
Think
call
of-
it not an experiment, then we don't need to have an independent variable. And
All
we don't
these-
need to take on, hang on, we don't need to take on the burden of proving causation just because we don't call it an experiment. That's how you guys are getting yourself out of this puzzle.
No, we don't prove it.
Well,
We don't
no,
prove anything. in
excuse me,
experiment.
but
We just
I mean,
show a change. We just show, again, in the experiment, we want to see a change in the independent variable. We see that. That provides evidence. Only evidence. There's no proof. It's only evidence that this theory. Now we can do thousands of tests over and over again and change them slightly. Like I said, more time, different latitudes, all these things with the construction of the pendulum itself. All these things we can do. They all will show the same thing. They're all supporting the hypothesis because the mechanism that is
Portably, right?
Hold on. The mechanism that is the Foucault pendulum is based on this swinging pendulum that kind of forms this plane that's almost independent in space, but not really because it still has an axis that it rotates or swings from, and that on the surface changes that plane as it rotates, and that's what causes the precession. That's the theory.
But what causes the precession?
The correlation of all of those different data points is what causes the precession.
Yeah. What was the
No,
cause?
all those data points are the causes of all the data points changing, all the things we see are caused by the rotation of the Earth, which is something
the
we
rotation
can't
of the Earth.
change. We can't change the rotation, but we can change things
So you
that
can't claim
will.
it to be Earth rotation if you
No,
can't manipulate it.
Oh my God, it's
Okay,
like crazy.
so real
town
quick,
here. Seriously.
rotation of the Earth can't change. Latitude, can you change that?
Yes.
What's that?
Yeah.
Okay, so latitude is your independent variable, not
The
rotation of the
experiment,
Earth.
yes. I agree.
Oh, you still don't get it.
experiment-
It's almost like
Yeah.
crazy town here. Seriously. We know that. We've talked about this. You're talking about two different causes. The cause of this Foucault pendulum process is rotation of the Earth. How we prove that, or how we support that with evidence, is by doing these experiments. And you can think of a million ways we can make these experiments. A million ways we can
That'd be
construct
affirming the
things. Hold on,
consequent
no,
because
no, it's not.
you're
It's not.
presupposing.
No, you're interrupting me now.
Yeah.
No, you're
Well, because you're gonna go on and on and repeat yourself.
I'm
You've
not.
said it 5
I'm
times.
trying to slightly change my response so you can understand, because you keep on responding, telling me you don't understand. But your response is telling me,
No,
well,
I
you still
never
think that-
said. Hang
you-
on.
you-
Don't
you
lie
still-
about
hold
what
on,
I said.
will
I
hang on
never
when I'm
said
done.
I
Hold
don't
on.
understand.
I will hang on when I'm finished. Hold on.
You go
It's like
on and on and
gaslighting of what he
repeat
wants
yourself.
to think that you think.
Jesus Christ.
It's like
No,
an
it's not.
inverted
No, it's
gaslighting
not.
thing.
He said,
Zanik, you know what the truth is, dude? The Foucault's pendulum is, even if we were on a rotating sphere, hypothetically, it's just a terrible way to figure out that you're rotating. Even if we were rotating, it's just faulty. It's not an experiment. It's
Exactly.
affirming the consequence. It's just a mess. So you guys should just
No,
give
dude, what are you
give
talking
that
about?
one up and try to find other ways to prove it's rotating.
What are
'Cause
you
this one's
talking
just
about,
terrible.
man?
He's
What
right.
are you
So,
talking about?
Yeah.
hang on. Yeah. So we do the observation of the pendulums at different latitudes. Should we stop there and just say, well, it processes, but that's it? Should we try to figure out
That's all you could
what's
say.
causing? No. What could be
Yes. Try
causing
to
the
figure out the cause and get an independent
Exactly.
variable that you can actually manipulate, so you can actually prove it's the cause. If you want to have it be something that actually shows a cause or is a scientific experiment or anything of the sort, yes, you'd have to find an independent variable that is the cause, and then you would actually have something. Without that, it's a parlor trick. It's just a correlation. It's not scientific. It's not an experiment. It doesn't have
Gio, I've got some
any
bad news.
isolation of any cause. Therefore, it's useless to use it as a claim to claim that it causes XYZ when you don't have a proper way to show that.
Gio, I've got some really bad news for you. Every experiment is a correlation. There's always the possibility of a different
No,
cause.
it's not.
The phrase
that's not
correlation
true.
is not causation
Yes,
is
it's
about
not.
humility in your experimental processes. It doesn't say you need to do the right kind of experiment to be sure of causation. It is you need to be aware of the problem and you need to think about
So
it.
my rooster,
Every experiment
my
is a
rooster
correlation. Everyone.
crows every morning, and the sun comes out. So it's fine that my rooster is the cause of my sun coming out.
That's a
You can,
hypothesis.
every experiment is a correlation. Every experiment is a correlation.
That's a correlation. What I just mentioned.
Yeah,
But
It is.
not a causation, is
but
it?
you
It's
could-
not the
you could-
cause. It's not the cause, right?
You could test
Correct?
that. You could test that. Was it like
But,
hot
but
days?
is it the cause?
Hot days
It's,
increase.
we know that it isn't the cause, right?
We know it's not the cause.
Well, because we can.
No, but you could say it happens every day. Like my rooster crows, the sun comes up. Therefore,
So have you ever been around a rooster? They crow
Rooster's the
all
cause.
day, just all day. It's crazy.
What's the
And
same
then
logic
this
of
is what-
what's going on though? It's analogous. Go ahead.
But check it out, Gio. Check it out. You could actually manipulate the rooster, though. You can remove the
Yep.
rooster from your farm and figure out that your rooster is not the cause of the sun coming up.
Right.
That's the difference. Foucault's
that's-
pendulum, you can't. You can't stop Earth rotation. You can't manipulate Earth rotation. That is the thing that has to be proven to begin with.
No,
Beast, it gets worse
actually-
than that with the rooster. You could say every time the sun comes up, it's caused by a rooster crowing somewhere. You
That's
could
exactly what I was about
manipulate
to say that.
that and get rid of all of the roosters. So there's
Wait.
way more ability to test rooster crowing, sun comes up, than Earth rotation via Foucault pendulum. I mean, really
Agreed.
emphasize
Daddy,
that
you
word
missed a
faux
rooster
and
somewhere.
Foucault. Really, we should focus on that.
Wait, we
You
can,
missed the
we
rooster
can
somewhere, Galley.
manipulate the Earth's rotation. Someone just said that can't be manipulated. Yeah, we can.
How?
Yeah.
You got a space,
Because
and then it's not.
the
a problem.
theoretical. No.
Hold on, I
the
want to hear this, you
theoretical
guys. Let him talk. Go ahead.
Yeah, no.
Wait, he's saying
The
that we can manipulate
theoretical-
the Earth's rotation?
We can very slightly. The theoretical prediction is that the rotation rate of the Earth will depend on the distribution of mass from the Earth's center. So if we take a very large amount of mass and move it to a higher or lower elevation, it will speed up or slow down the Earth's rotation by a very small amount, but a calculatable amount, which will then have a very small effect, but a calculatable effect on things like Foucault's pendulum. So if we lift a very large mass of water from a low lake and pump it up into a high reservoir, there is a calculatable prediction about how that will affect all of these other things like gyroscopes and pendulums.
Has that ever been done?
It has been.
Found out that
Massive infrastructural projects around the world have changed the length of a day by very small fractions of a second.
Even if it
Nice.
has been done, do you see the glaring issue with that? Because you're presupposing that Earth is rotating and has
Exactly.
some type of effect on it, and then you would be using that to prove the very thing that you're presupposing.
I have never said, and
no.
it's
You
a straw
totally missed
man
the point.
of my position and the position of most people here to say that we have ever claimed like absolute, like epistemological certainty. Like we're claiming the opposite. Like we will, well, at least I will, and I think most other people here will always accept that there is some possibility that we're just completely wrong in what we think is the most
Ironically,
likely
that's a
possible
straw
explanation.
man of what I said because I didn't claim you claimed epistemological certainty. I said the entailment of what you're saying is a presupposition that Earth's moving to then look for evidence of Earth moving. So first you say Earth moves, effect happens, this is what
Well,
proves or is evidence for Earth moving.
let me
So
let me re-
ironically, while accusing
No.
me of straw manning you straw manned what I said. I never said you had any
let me
type of epistemological or provable
people
claim.
made that claim. Let me reframe what I say. Okay, so
No one
I
made
don't
that
even have
claim.
to.
Oh, good. Yeah.
I don't even
Let him
have to
try it.
directly invoke the rotation of the Earth. Let me just put it this way. We've been talking about independent variables like latitude and time and stuff like that. The globe model of the Earth makes a prediction that there is another independent variable. That independent variable is the mass of the Earth itself in altitude. It predicts that if we take a huge amount of mass somewhere over in China and lift it up from the bottom of a lake to the top of a
ZZ.
mountain, that will affect the precession rate of a pendulum here in America.
But
So
dude,
that's a prediction. It's a prediction
you
of correlation that's testable.
You presuppose two things: globe
No, I'm not
and mass of
presupposing
the
anything.
Earth.
I'm
No.
pointing out a prediction. I'm
No,
saying
listen.
a model has
Listen to
made
what
a
you said,
prediction.
though. Yeah. Okay. You're
if you
presupposing
say
the model
if,
in question.
No. You
I'm
misunderstand
not
badly if you
presupposing.
think that's a presupposition. It is saying
That is a
if you,
presupposition.
I'm not
this
presupposing
theory
the truth of
predicts
the
this
model.
result. You don't need to be presupposing the theory is accurate. You're just saying here's how you test the theory.
I mean, if
I'm
you
not-
yeah,
could,
you just if you
if you
just
could
put
change
if in
the
front of
language,
it,
if you,
if the Earth is rotating, this is what we should see by
Yeah.
such and such. Yeah.
Right,
It's-
and then
I'm
we
not
use the
presupposing the
thing that
truth.
we see as proof the Earth's rotating, or evidence the
No,
Earth's
it's not a
rotating.
proof.
That's affirming
It's
the
a
consequence.
hypothesis.
Here, I'll give you a flat Earth
I'm not even going there.
example. Let me give you a flat Earth
No,
example.
I'm not even asking you to
If
accept
Earth was flat,
that
then
interpretation.
level will always find its then water will always find its level. Water always finds its level. Therefore, Earth is flat.
I'm not asking you to accept any particular conclusion.
No.
I am
Do you
making
see
a
the problem
predictive
in that
claim.
statement, though?
No, because you're misinterpreting where I'm going with it.
You're
I am not
talking
demanding.
through people, accusing
No,
them
no,
of
no, no.
straw manning and misinterpreting. You're just
Yeah,
talking
no,
through
because people
people.
are attributing things to me. I'm not saying. I want to be clear in what I'm saying. I am not
And
demanding
you
that
are.
anyone
It's
accept
so
any
frustrating.
predict. No. I'm not demanding that anybody accept any conclusion whatsoever. I am
No one
making a
is
very
saying you are.
specific.
No one is
Yeah,
doing
yeah.
that.
Just let
Very
him
good. Then I can
finish at
continue.
least.
Then I continue. Then I am making a very specific, bettable, testable claim. If we move a large mass from low to high elevation anywhere on Earth, it will affect the rate of the precession of pendulums everywhere on Earth. That's the testable claim, and we can take bets on it. We can take bets on whether or not this correlation will happen.
Ah, dude, it's still you're not understanding that you're already in a fallacy of
No,
affirming
there's
the
no fallacy
consequent.
here.
Yes, you're
I
assuming
didn't
Earth
even.
is rotating.
I didn't say that. Now you are projecting onto me because I literally did not say anything about
You
rotation
are
and all of that.
assuming the Earth is rotating.
Nope.
In
You don't
your
even know why I'm saying
example,
this. No. You don't even know why I'm saying this.
hang
I'm
on
just
for 1
claiming
second.
a
ZZ
prediction.
Pop, you have this issue where you talk through people as if you don't hear what they're saying. So what
I
is
didn't say
he
what you're saying I said.
claiming that you're presupposing?
He's saying I'm presupposing that the Earth is rotating, and that's
Why
why I
is
was
he saying
very
that?
careful.
Because he
Because
doesn't
he thinks that's
understand.
what I'm saying, and
Because
I
I
Because he
don't
doesn't
clearly
understand.
understand.
and I didn't
Alcides,
say
can you shut the fuck up? ZZ
Never.
Pop, go ahead. Why is he claiming that?
He believes that that is my presupposition, and I am correcting that I'm not saying that. I am refusing
What is
to
that
say
based on, though? Why
no,
does
no.
he
I
think you
listen.
presuppose that? Why does he say you
That's a
presuppose
matter
that?
of his psychology as to why he thinks that I
Oh
presuppose
my god,
that.
my
Why does
psychology.
He doesn't understand.
Hold on, Galley,
He
Galley. I
doesn't
got you.
understand the
I got you.
scientific
ZZ.
method.
I
ZZ.
can't be asked to
You
explain why
said
he
all of
thinks
the
he does.
you said all the pendulums, their precession would change. Okay.
Yes, I'm making a bet. I'm not
Yeah.
saying why I'm making the bet. I'm just saying I'm making the
You're
bet.
already
I am
presupposing the
no,
cause
no,
for
no,
the
no, no, no,
precession.
no.
No, you're not.
No,
It's
I'm
a
not.
hypothesis. It's just he's going to
No, no,
support
no.
the hypothesis by
No,
experimentation.
no.
You
And
make a
no, no.
hypothesis that the
No
Earth
hypothesis.
rotates, and then you show it.
No
Fifth
hypothesis.
Glober to pop
No,
in.
no, no.
Okay.
No. I'm a betting man, and this is about money. I am refusing to tell you why I think this will happen. Okay? I am refusing to give you a causal
So you're just being
explanation.
dishonest.
No. I'm simply saying I predict this will happen. Will you take the
Predict what
opposite
will
side of the
happen.
bet? That if we move a large amount of mass to a higher elevation, it will change the rate of precessions of pendulums on the Earth. All
Why?
I'm saying is I'm making that prediction. I'm refusing to give you a why. I'm just saying
Yeah, so you're
this
being
is a
bad faith.
prediction. No, it's not being bad faith. I don't need to give you a why to make a prediction.
What? Because you know,
I
if you
don't.
explain the why, then you're already in a presuppositional fallacy. Yeah, you're
Yeah, what if
presupposing the Earth's rotation.
Yeah,
right,
but
what if
can
we grant that
kinda,
it does happen? What if we grant that it does happen? What
I'm
would
not
be the
asking you to
cause of
grant
it then?
anything. I'm just asking who would take the other side of the bet.
I mean,
Oh,
okay, can I get just 10 seconds here? Okay, so if you could actually change, like move water to a higher
We
elevation.
can.
Well, let me just speak, dude. Hold on. Just
Yeah.
can I get 15 seconds?
Yeah, please.
Okay, so if you were able, because I'm trying to actually be good faith and give a response here that you might have some interest in. Okay, so in theory, if you were able to move water to a higher elevation and do so in a way that you could noticeably see a change in the sidereal motion of the sky, to me, that would actually be somewhat compelling that you could change the sidereal motion of the sky with simply changing the latitude of some water somewhere on Earth. Doesn't mean that it would prove anything, because I also hear what that you're also assuming that in the same way that even if you were to say that that the actual cause of the change is because you pumped the water, which then is, you do have the presuppositions of that it's because you're on a ball that's rotating, the ball has a center of mass, there's mass involved. So can you kind of like partly concede on both sides, like at least like agree that is still, you are still presuming what the cause of it is, but and then on the other side, could folks agree that would be, I mean, you could literally change in the sidereal motion with changing latitude of altitude of water on Earth, that is at least something more than the Foucault's pendulum has?
I'm not taking a position on any causal explanation. It's we pump the water up, we do the timing of the
Then you're not making
sidereal
a
day, we let it
hypothesis.
run down.
It's not true. He is
Well, I'm
making a
making a
hypothesis.
prediction.
What's the
I'm
hypothesis?
He's making a prediction, and he's based that prediction on evidence. It's different than an assumption. Hold on, it's different than an assumption. Assumption, basically, or pre-assumption, is where you just presume something without even making any attempt to try to prove your assumption. Whereas a prediction,
like Earth rotation, right?
Whereas a prediction is where you say, I believe the Earth is rotating based on these observations. So therefore, I'm going to make the hypothesis that the Earth rotates, and to demonstrate that, I'll do these following experiments. If the experiments fail, if the experiments fail, I haven't proved anything. I haven't, supported my hypothesis. I have to change my hypothesis. On the other hand, if the experiment succeeds, then I have supported the hypothesis, and I move on. No, that's you. That's you misinterpreting the scientific method.
Hold on. I could say the exact same thing by
Absolutely,
saying, I
but then you have to prove it.
You guys, let's not interrupt each other. Let's try to give each other the mic. Let them respond.
I believe the Earth is flat. Therefore, water will always seek level. Water always seeks level. Therefore, the Earth is flat.
No,
Do you see anything wrong with that?
Sure,
you see anything wrong with that statement?
Yeah. Well, let me finish. Here's what's wrong with it. You didn't follow it up with enough experimentation to demonstrate that the reason why the Earth is flat is not just because that water follows its level. Because if you examine that water closely down at the molecular level, there's a curve to that water.
If
So you got
that's
a
what you
problem.
think is wrong with what he said,
It's not that. It's just that's one way to prove. That's one way to prove what's wrong with what he said by demonstrating that his conclusion on the
I don't know
Earth
how to
being
make it any
flat,
more simple.
an object that's so much bigger than the water that he's measuring,
Great, Angelo,
making his
can I just try
claim.
to ask you something?
I'm going to
and you
finish what
can-
I have to say.
Well, because you're
Now,
responding to something he didn't say.
Specifically, what he said was he took one hypothesis, the Earth. Basically, he didn't even do that. He jumped to the conclusion without making a hypothesis. He said, "Water finds its level, therefore the Earth is flat." He
No,
didn't
what he
go
said
the other
was,
way
I
around.
believe the Earth is
If
flat.
if you make,
Water
I believe
always finds its level. Water always finds its level, therefore the Earth is flat.
Okay.
So, Angelo, would you agree that that's an, hold on, Angelo? Would you agree that that's an affirming the consequent logical fallacy?
No.
What
Okay,
he
then
said
you
is
don't
not.
know
No, what I'm saying,
Yeah,
okay,
you're done.
if
You
he's
don't know
affirming the
basic
consequence,
logic.
if he's affirming if he's making basically a logical fallacy, basically making a statement based on logic, yeah, of course he is.
He
But
gave you
if
an
he's,
absolute
hold on, I'm not quite
home run
finished yet.
affirming the
For fuck's
consequent
sakes,
fallacy to see if you knew basic
for
logic.
fuck's
and you
sakes, I'd like to
demonstrated you
finish.
did not.
Like, great Angelo, just real quick, brother.
So, no, I'm going to finish what I had to say. He didn't.
Another 5 minutes
He
of
failed
bullpen
by
rambling.
demonstrating. He failed by demonstrating a logical fallacy, but he didn't demonstrate any kind of scientific method, which is what we use when we make our claims. We don't touch
Incorrect.
logic. We do not touch logic when we make our scientific claims. We
That's
specifically
completely
make a
incorrect.
hypothesis.
Science depends on
I'm
logic.
being talked over again. Someone mute the motherfucker before I get
You
pissed.
saying
I'm
so many
pissed.
things.
You guys,
It's a shame.
hold on, wait, pause. No matter
Let's go back to
how,
zzpop.
no matter how wrong Great Angelo is, just let
Shut
him
the
finish
fuck up.
entirely. I'm trying to give you space to talk.
Yeah, well, shut up by the way you're doing it, okay? You're being insulting. Okay? You don't like what I'm saying or you think I'm wrong, then tell me afterwards when you rebut, not when you fucking tell me to tell other people to shut up.
Let's
You
go
be
back to
respectful
ZZ.
to this old man or you shut the fuck up yourself.
I just
Now,
stop.
here's what I'm going to say.
Everybody stop
I'm
for
gonna
a
finish.
second. Everybody just stop. Dude, Angelo, he was actually modding to say to people, don't interrupt even if you disagree. You misunderstood what he said.
Oh,
Can we
no,
just
he
reset?
clearly insulted me.
He said, even
No.
if you think he's wrong, don't interrupt him. He was actually helping you to not be interrupted. Can we just reset? Go ahead, say your statement. Please try to keep it concise enough that other people want to respond. Just go ahead.
All right. The problem I'm having is that you can use logical, logical or illogical fallacies, whatever you want to use, as far as describing logic. Yes, but we're not talking about logic when we're trying to describe the shape of the Earth, or for that matter, whether we believe it's flat or whether it's a globe. We use the scientific method. You use a hypothesis and you demonstrate experimentally to see if it supports your hypothesis. You don't jump to the conclusion and say, I'm going to find out that the Earth is flat. No, I am going to find out what the answer is and whether it's flat or if it's a globe. I don't make any presumptions whatsoever because the
That's the
first thing
point.
I'm going to do is question my results the minute they come in, and I'll have my peers question my results also. That's the point. It's not about logic. It's about the scientific
Dude, you can't
method.
just
Okay,
monologue.
Can I respond to
It's okay.
that?
It's okay. No, wait. Let me
It's not a
respond to that
monologue.
because
It's actually trying to clarify. Come on.
Hold on, guys. Great Angelo. The reason why I said what I said was to show the analogy of what you guys say about Earth rotation. I could say the same thing about Earth being flat, right? It's presupposing the thing in question. If I presuppose that Earth is flat, if I say I believe Earth is flat, therefore water will seek its level. Water seeks its level, therefore Earth is flat. I'm saying that on purpose to illustrate affirming the consequent fallacy. And the reason why logic is 100% important is because that's exactly how the scientific method operates under, right? You're using a logical statement. You're controlling the IV and in order to figure out what's causing the DV, the dependent variable. You're trying to see what actually is the cause, right? That's a logical statement.
Here's where it's different. Here's where it's different. The difference is you made your presupposition before you made any observations. Because if you did make an observation that water was flat and therefore went to your conclusion that the Earth was flat, you've already made an observation. You're now making a hypothesis, and you have to test whether water actually does find its level and shows that the Earth is flat. That's a scientific method.
what
But
you're doing with Earth spins.
what you did was you jumped the gun beforehand, made the statement, the Earth is flat.
Okay.
Therefore, I'm going to look at water. Water finds its level, and therefore the Earth is flat. You've done nothing scientific at all.
I'll give you the
No,
equivalent.
The
of
equivalent.
side.
You've never,
Hold on,
Go
hold on.
ahead.
wait,
Wait,
let me build on what
Zanick,
Great Angelo said.
Let me just go
Now
back and
Zanick,
forth
let him
with
go back.
just real quick. Great Angelo, because I want you to see, like, okay, I'm going to give you the equivalent of the globe side, okay? I believe Earth is rotating. Therefore, if I use a Foucault's pendulum at different latitudes, I will get different precessions. I use a Foucault's pendulum at different latitudes and get different precessions. Therefore, the Earth is rotating.
Did you make an observation before you said, I believe the Earth is rotating?
No.
Well, then you are definitely not doing the scientific method, and you're making a fallacy, and that's not how. Because the observation is, I look up in the sky and I see something that appears to be moving, which are the
You see
stars.
something
So
that
it's
appears to
either
be moving.
right. Hold on
You
a
see the
second here.
stars moving.
Can you not interrupt me?
Or do you,
Is there a problem with your hearing earlier about people telling you not to interrupt me?
My bad. I just thought you were making an observation of the
No,
Earth
I'm
moving.
fucking trying to answer his question. Now, what I said was the difference between you and where you don't make an observation ahead of time. Science makes an observation and says, why? Why is this happening? Why is the sky moving across? Why are the stars moving across in the sky? One of the hypotheses is maybe the Earth's rotating. And so they go ahead and they try to measure to see if there was any way to measure the rotation or to demonstrate that it's the Earth that's doing the moving and not the sky itself. That's the one reason.
That was the first thing they did, right?
The counterclockwise motion in the southern hemisphere, or the opposite motion in the southern hemisphere, definitely demonstrates that we're probably on a sphere. Or you'll have to have another explanation why the stars are going in the other direction. So that's the reason why we made an observation first, then jumped to a hypothesis to come and support, and then get evidence to support that hypothesis. We didn't just say the Earth's flat. Now I'm going to prove it.
Right.
Well, you said the Earth's rotating, and therefore I'm going to prove it. And then every single
jump in real quick.
experiment to show Earth rotation or Earth's motion around the sun has failed.
What did I ask you? I never said the Earth's rotating. I said I made an observation first and came to the conclusion, or to the hypothesis that the Earth is rotating.
Great Angelo,
I made an observation first.
You said it's a possibility. You just said that.
Great Angelo, I got a quick
course.
observation. Real quick between you guys. I'm listening. I'm hearing you both have points. But what Great Angelo is trying to ask you is that you're not. You just said words. You didn't make any observation. You didn't formulate any test that could prove or could show evidence for your assertion that the Earth was flat. We did. So we kind of said
water looks flat.
Hold on. No, you can't say it looks like. What tests have you done?
No, I can't say
Actually,
it.
now he's doing science. If he says water is flat first and then says, I'm going to demonstrate that, that's correct.
Right. He completely demonstrated how the Foucault pendulum is affirming the consequent in the same way.
It's not.
that
It
his
really
argument-
It's not, and you're wrong. You give up on this, guys.
Just
Come on.
hang
for
on.
Christ's sake.
You guys,
Wasn't you
pendulum-
just crying? Wasn't you just
Stop.
crying about interruptions?
Yeah, you just interrupted him. See, it takes patience on all sides. Angelo, you just interrupted him. Doesn't he allowed to have the floor? Go ahead, Galley.
So Biasticles' example of the Earth is flat, water seeks its level, therefore the Earth is flat, was to contrast the Foucault pendulum that you guys would make a claim that it proves or shows evidence for Earth rotation. It's equivalent.
Zanick, hold on.
Please stop. Zanick, just stop taking Adderall. He was doing that to show an equivalence between your claim about the Foucault pendulum, and if you take issue with his claim about the Earth is flat because water seeks its level, you would equally be taking issue with the Foucault pendulum proving Earth's rotation.
I got
was not the Foucault pendulum
Eloquently
an
said.
experiment used to demonstrate Earth rotation? Yes or no? It was.
Wait, what was your question? Wait, I missed the question. What was the question?
The Foucault pendulum was an experiment to help demonstrate that the Earth was rotating. How did they come to that experiment? They made an observation before they even built the pendulum that there was some indication Well, tell me why they built the
Well,
pendulum.
Angelo,
Yeah,
your
it's not,
observation was
Great
you
Angelo,
saw
it is
stars
not an
moving.
experiment. I could prove that
Yeah.
with 2 simple yes or no questions. Easy. It's
Go
not an
ahead,
experiment.
answer that first. Go ahead and come back with that, and then I'll finish what I had
You
to say.
said, was it not an experiment to show the Earth's rotation? I said, it is not an experiment. And I could demonstrate that with 2 simple questions. I answered it.
It was not an experiment. Like, you guys
All
have
right,
a
you guys-
weirdly narrow view
Firstly,
of
you guys are
Wait, I was
You
next
guys are
outside.
letting him get away with what he said, that it's an experiment.
You didn't have any answer.
Yeah,
for
you guys
that.
are
Wait, it was my
fogging
turn.
and
Great,
smoke
Angelo.
bombing because
Wait,
you
let me
know
just
we
say
can't
this. Great,
defend.
Angelo.
That's an experiment. You're fogging and smoke bombing.
You can't say
Oh.
that I think the Earth is flat, and if things are flat, then the water should not be moving or should be a level, whatever. And then you say, and therefore, because we look at water, it's level. What Angelo is saying is that
yes, exactly. That bodies
I'd like
your,
to respond
that's
now.
exactly the
Stop
point.
taking the Adderall. Stop taking Galley.
That's exactly the
Listen
point.
to me.
That's why
Listen to me.
we
Let me
said
finish
that
the
5
sentence.
times.
Let me
Zanick,
finish.
you have
How many
to
times do I have
not
to
be
say this?
tracking to say that.
Let me
We've
look.
said
all
that
you-
exact point 5 times.
Incorrect.
And now
That's
you're
right.
saying
That
it
is
like
my
it's some
point. You're not
revelation
listening.
you came to.
You're not listening. Listen.
That is
if
our
you want to say
point.
that's great.
Come on, guys,
great.
guys, let him talk. Let Zanick talk at least. Come
Thank
on.
you.
Go ahead, Zanick.
Yuck.
Just
So
make it
if
quick.
you say that by just saying we should observe this and we do, that's not an experiment. If we say we think the Earth is rotating, therefore we're going to devise a piece of equipment or some experiment that has some motion involved that actually shows that that supports the hypothesis that the Earth is rotating because of the effect on this particular experiment, then that does support the hypothesis. You just
Hold
can't
on,
say.
Zanick.
You just can't
Got
say
one
Earth is flat and water should find its level and that's what we see. End of story. That's affirming the consequence.
Rules for thee,
Yes,
but not
it
for me
is
type
equally
shit.
as much as
Hey,
the
I'd like to
Foucault
respond now.
pendulum proving Earth rotation is. Yes, it is.
Okay, the
That
Foucault
was the
pendulum was.
entire point. Why
The
do you
Foucault-
guys switch out? So Great Angelo makes a claim.
You just said that
about
is the
Foucault
entire
pendulum
point and
being an
ended your
experiment,
sentence. So
and then
thought
I
you-
rebut
Jesus.
that, and then Zanick makes a claim that's equally as ridiculous. I rebut that, and then you're gonna switch out. Then
You didn't rebut
Alsadius is
anything.
gonna come
We're not
in.
done yet with you yet.
Well, I am going to come in mostly just to
I'd like
point
to
out.
finish what I'm saying.
I mean, I'd
voice
like
added back
Great
to the
Angelo
prime
to
movement
address
text.
how I refuted his point. I'd like Zanick to address how I refuted his point, but you
Okay.
guys just never are. You just talk.
I'm addressing your point right now. You said the Foucault pendulum was not an experiment. It absolutely was an experiment.
I said it was, no,
groundbreaking
I didn't.
one
I said it
that
was not an
French
experiment.
physicist-
I
I'm
could
not
prove
done
that.
yet. The French
I said it was
physicist
not an
Leon
experiment, and I
Foucault
could prove that.
demonstrated in
He attacked
1851.
you.
Come on,
He ran
man. You're
away.
interrupting me every other word.
He built his Foucault pendulum.
that's not- he
At
didn't-
that
he
time,
didn't repeat
that's
his
an
question
experiment.
correctly.
Now, I asked specifically, what was the observation he made? He was observing the motions in the skies and tried to figure out if there was a way that he could demonstrate that it was the Earth that was rotating and not the sky. And that was the whole purpose behind the experiment. So good luck with trying to tell me it wasn't an experiment.
Okay.
So your
Foucault
observation
pendulum was
was
an
you saw
experiment. What's
stars
the?
moving, and then you
Hang on, we'll
presupposed
start
that the
over
Earth was
again.
spinning.
What's the
No, he
independent
won your
variable, Great
tongue because
Angelo?
it does that.
Zanick, hold on, guys. Take a breath, everybody. Galley, what was your 2 questions you wanted to ask Great Angelo? Go ahead.
Oh, if he's willing to answer them, he never answered.
You willing
if
to
he was
answer
willing
it, Great Angelo? He could show you in 2 questions. Galley's claim he can say in 2 questions, or he can show you in 2
Go on.
questions that it's not an experiment. Okay, go ahead.
Okay, do you agree that empirical evidence refers to evidence gathered through direct observation or experimentation rather than relying on
Yes,
theory or
go on.
speculation?
That's partly true. Go on.
Do you agree that it refers to evidence gathered through direct observation rather than relying on theory or speculation?
Yes or no?
Yeah, everyone agrees with that.
Great Angelo. Hold on, wait. We got the one who's getting the questions asked to him. Great Angelo.
Hang on. I'm at my door. Hold on.
Oh, okay.
He's on the ropes.
Oh no, he's got to close his door. He's got to
It's not
close his
going to
door.
work. Galley, this technique is not working. You just
Guys,
keep
he's taking more.
My
Everyone-
DoorDash
everyone
Dash
stop.
just showed up. If you don't mind, I'd like to eat.
He was just getting his food. All right.
Okay.
Go
Either
back to the question.
What's your
He's
question
picking
about
up his Adderall, guys.
Go on. What is your question about empirical evidence?
Okay, do you agree that empirical evidence refers to evidence gathered through direct observation or experimentation rather than relying on theory or speculation.
Sure.
Awesome. Do you agree that in scientific experimentation, you have to have independent variable, the thing you change, the cause, and a dependent variable, the thing you measure, the effect?
Let him chew.
Independent variables. Yeah, I'm chewing my food. Thank you.
Yeah, the thing you change is the manipulated variable, and the things you keep the same, those are the independent variables.
Hey, hold on, wait.
No,
I want to
no,
hear. We
that's
gotta
a-
hear from Great Angelo.
That's a control variable.
Hold
keeping
on.
this thing the same.
Hold on, guys. Great Angelo, do you agree with the second question? Yes or no?
Yeah, you have to have independent variables. Yes, of course.
Which
But-
is the cause, the thing you change, and a dependent variable, the thing you measure, the effect.
Okay, no, that's where you're wrong. In the case of independent variables, it can come in a lot of forms. You can actually change the actual environment that you're dealing with while you're doing an observation, or you can change where the observation is being held at, taken place at, which is not,
What kind of
which is,
scientific
which
method
is
did you guys learn in school?
okay.
What the hell? Sorry.
You guys
Okay.
didn't listen
For
to
one
anything I
thing, you got to understand, a lot of you guys in the flat Earth community are really bedrock scientific method people who will take that list of 6 or 7 that you learned in school or even wherever you're picking it up and think that you have to follow it exactly. I'm
Well, you just said the independent variable is
I'm
a
going to
thing you
finish this for a
change.
second. Hold on. I'm going to finish this for a second. I am an observational scientist. Working in entomology, it's very difficult for me to actually change variables in many cases. When I'm watching and making conclusions, and then I have other colleagues watch and make conclusions based on observations alone without changing any variables, just to see if it confirms what we're seeing and explains the whatever it is we're observing. A lot of times we don't even need to change any variables and can come up with a very concise, agreed upon result as to what we're observing. So your claim that you have to have variables in that sense is absolutely bullshit. Okay. Now, take observation science aside, and when you're dealing with physical science, where you're actually making measurements and you're actually watching results as a result of having to do changes, for instance, in chemistry, changes in temperature to find out boiling points, things like that. Those are all ways to do experimentation using changing the variables. Now, where are you going with this? Because I would love to hear how you think that this is going to make any difference in how we do an observation to decide whether the Earth is a globe or flat.
Okay, so you dodged the second question.
No, I answered the second question. I said you didn't necessarily have to have an independent variable to make an experimentation work or an observation confirmed, or to make an observation confirmed.
I feel compelled to ask a quick question.
Zanick, it
Zanick,
isn't your opportunity to tack on points when someone's trying to respond.
No, because I think I have to bridge.
Okay, it doesn't matter. Let him finish first, Zanick. Come back later after this. Okay.
Yeah, let Great
I'll just
Angelo
type it in
and Galley
text
go
chat.
back and forth, you guys. Please. Let them go back and forth. Just them two. Thank you.
Okay, an experiment, by definition, involves manipulating one factor, measuring another factor, and observing
Cause and
whether...
effect. Yes.
Okay, you just disagreed with that when you said no to question 2.
No, because I wasn't
So let me
giving
finish
you...
now. Let
Go
me
ahead,
finish.
finish.
I didn't interrupt you. I've been interrupted a dozen times by
Go
you
on,
and Zanick.
stop moaning and crying.
So you've interrupted me to say stop moaning and crying?
Yeah.
Okay, so in an experiment, you're manipulating one factor, measuring another factor, which you just agreed with, which you just disagreed with 5 seconds ago, and then observing whether changes in one correspond to changes in the other. So if you don't change the independent variable yourself, you're only observing a correlation. You're not testing causation. Manipulating the cause allows you to control for other variables and see if your change actually produces an effect.
Interesting how you brought that point across, because the person who claimed that they would make an observation that the Earth was flat because water finds its level didn't even bother to change any kind of variables or whatever. So my point that I'm getting at... Okay,
That
hold
was
on.
the
The point...
Dude, that was the point.
Great
That was
Angelo,
your
he
point.
didn't claim that. He said it would be equivalent. He said it would be equivalently absurd for me to make this argument to highlight the absurdity in the Foucault's pendulum, and this
How is
just
it?
illustrates how your failure to track what the conversation is about.
All right, I need to. You said I could jump in here real quick, and I'd like to because both. I don't know if Great Angelo was there when I was
Do you
talking about
respect
the.
Great Angelo, Zanick?
I do, and I think he
Okay,
actually
then
gave me a
let
position.
him think for
Well,
himself.
I think he might
Just
benefit from.
let Zanick. I promised Zanick he could respond afterwards. I'm done. So go ahead and leave him alone.
I
But wait,
appreciate it.
I don't think.
Great Angelo,
Okay.
just let God. It could be just a bunch of guys talking, and doesn't be so.
You may
So
understand it, Zanick, but I want Great Angelo to understand it. Do you understand?
I
Like,
know,
I
and I think
want
I
him to
might.
get where we're coming
I
from.
will stop if he heard me, and I don't have to say it again. I'll be
He
very
did pass it to you. He
surprised.
passed it to you. Go ahead. Go ahead. Sorry.
Great Angelo, look how long it took me just to get a word in. Great Angelo, were you there when I was talking about, I thought, a little bit of misunderstanding between the hypothesis cause and effect, which is really the cause and effect of what we're talking about, and these individual experiments would also have the independent-dependent variable relationship, which is a cause and effect relationship, which doesn't relate generally into the broader picture, which is the cause and effect of the hypothesis. Meaning, like, we have time can be an independent variable. Is that the cause of this particular effect in the hypothesis? No, it's just a particular effect of we let some time go by. What did we see happen in this experiment? Oh, this is all these data points are giving us support for the global hypothesis, the idea that something is causing something else. The cause in that experiment is not the same, and they don't seem to understand it. And I think you might have heard